Hello, everyone. How are we doing today? Hopefully well. I wanted to start just by mentioning I have a new puzzle up. I know this view is terrible, but anyway, will the pen view be better? The pen view will be better. I have this new puzzle out, so if you are someone who does all of my puzzles or likes doing some of my puzzles, this is a 4-star 10 lines puzzle. Which actually is rated at 99% after 39 solves, which is quite unusual. So I'm very happy with that. I was very happy with this puzzle. So if you are inclined towards those sorts of things, I do commend this one to you. Alrighty. But in terms of puzzles we are going to do, we are not going to do this one today, although that would be fun. We are going to do this puzzle. I have to switch back to CTC mode now. We are going to do this puzzle by Jay Dyer. So this puzzle is called Overkill. This was voted for by the supporters. So if you don't know, I always start every stream with Simon always beats you to doing Zeta's puzzles. The last two have been eerily fast. Like, I think the past two, I think both Baby Dragon and 20 Lines, which I think are my last two Simon features, I think they were both thing. There was a higher voted puzzle. Which puzzle is higher voted? One moment, I have to go back and do the highest voted puzzle. Sorry, Jay, I'll do this puzzle later. I even refreshed Discord, and there were no 8-vote puzzles. There were only 7-vote puzzles. Unless Tristan's Discord is now the one that is out, but I'm guessing Tristan is telling me there was an 8-voted puzzle. Well, Tristan's not actually telling me what puzzle it is, so I might just do this one. And then we can do the other one later. I do Kropki. Okay, one second. Let me pull up this one, which Tristan claims is actually the most voted on. Be right back. Okay, I will trust Tristan. Can Tristan tell me who voted for this puzzle, since I do not have a list of the voters, because Discord is being weird. I don't know why, by the way, but somehow lately Discord is being weird about showing all of the votes. And Discord being weird about showing all of the votes makes it harder for me to do the most voted on puzzle by supporters. But I always attempt to do the most voted on puzzle from my supporters over on the Discord. So we will do that. Doomdiat, Luda, Tallcat, Russ, Chili, Chameleon, Eric, and David voted for this. So thank you all for your support. Zach thanks you as well. Much appreciated. If you'd like to get in on voting on puzzles, you can do so by clicking the join button down below. At the windmill tier or higher, you can see the list and vote. And at the moment, votes are incredibly powerful because there are about 80 puzzles tied at 7 votes. So that's a slight exaggeration, but it's not actually that much of an exaggeration. There are a lot of puzzles tied at 7 votes. So your votes are, like, from a voting theory point of view, your votes are quite potent. So if you're interested, and if you already have voting privileges and you just haven't voted, by all means, go through and do it. Will is hoping that Simon will today do Shrug, which would be cool. I do always, if Simon does a video on the day I'm streaming, I always will watch it on stream, which is always fun to do. I will take a second before we start the puzzle, by the way, to ask if you've not yet liked the stream, please like the stream. It is greatly appreciated if you do so. It helps people find the stream, and we are trying to get towards 2,000 subscribers. Wow, my brain. We are trying to get to 2,000 subscribers. I've been grading calculus exams all morning, brain. We're trying to get to 2,000 subscribers. We'll do something special then. But in the meantime, if you want to submit puzzles to the channel, I should mention that you're able to submit puzzles for 3 things. You can submit a Fog of War puzzle to the Fog of War challenge. You can submit a birthday puzzle for Tristan. Tristan's birthday is December 27th, if you want to use those numbers. Although if you want to make a birthday puzzle that is not related to the numbers 12 and 27, you're welcome to do that as well. And my birthday, I will do a stream for, which is January 5th, so if you want to do one for that as well, all 3 of those have submission buckets posted over on the Discord in the zetamath discussion. So it's going to be lots of cool stuff. I should also mention I'm intending to have several guests on the stream over the time when I am on break, so look forward to having a few streams where we have some bonus guests. It should be fun. I'm not on break for too long, but we can probably get in a few streams, so look forward to that. Alrighty, so now let's read those. Oh, I see DDX was grading Calculus 1 exams earlier this week. Yeah, I graded Calc 1 exams earlier in the week, and today I was grading Calc 2 exams. I do believe that the special guests might include Tristan, Eric. I might be able to get a hold of him to be one of the special guests. I also strongly suspect that the Tristan birthday puzzles will feature Tristan in doing the birthday puzzles. Alrighty, so let us read these rules. So there are activated cells rules. Oh lord, a 3.5 hour math final? That sounds terrible, Toto. What on earth? Why? I guess my qualifying exams in grad school were like 3 3-hour exams in a row, but that is just not a kind thing to do to a person, or even to a grad student. Alrighty, so let's see. An activated cell is the xth cell in from the outside of every row and column from both directions, where X is the first cell seen in the row or column from that direction. So what I read from that is if this is I should turn on the keypad or it probably won't work very well. If this is a 7 and this is a 3, then this cell... Oh, that was a bad example. If this is a 7 and this is a 4, then this cell and this cell are activated. This is 4 in from the right. This is 7 in from the left. We should put down a bet cell somewhere. I have absolutely no idea, but I'm just going to go here. If Rocky shows up, then Rocky might do that. Rocky might be grading finals as well. I think Rocky is also a math teacher of some description. There are many of us around here. So there is the bet tree. Okay, so I have no idea what the activated cells do yet, but just have that. Okay. Yep, okay, and the example seems to verify that my example is correct. I think the example that is given agrees with what I just did. And then we also know that cells separated by a black dot have a 2-to-1 ratio, but all of them are activated. So actually, if we're going to make yellow cells, or if we're going to make activated cells yellow, we know all of these cells are activated. Okay, that's very interesting. All right, so let's start by thinking about how in the world we're activating all of the cells in this row. Because getting 4 activated cells in one row is going to be tough. I can activate 2 of them from those 2 cells. All the rest of them have to be activated from columns. And so I can activate 2 of them from columns as well. One by having a 1 up here, and one by having a 9 down here. And so what that means is I need to have, and I'm going to be able to elaborate a lot more than this, but I'm going to need to have 1s up here, and I'm going to need to have a 9 down here in one of these cells. And then this cell is going to need to be a 1, 2, 7, or 8. And this cell is going to need to be a 2, 3, 4, 5, 6, 7, 8, or 9. Okay, so that all of these cells have to point to yellow. Both of these have to point to yellow cells, and I need a 9 and a 1 at the bottom. I was thinking someone was saying that this is going to be a 1. I don't think this can be the 1, because I think if this is the 1, we only get to 3. Because if this is the 1, then it's giving me a 1 in the column and a 1 in the row, and then I only get to 3. So that's not a 1. And the 1 on a black dot certainly can't be a 7. So this is only a 2 or an 8, which means, funnily enough, this is only a 1 or a 4. So we've got that. Okay. Now, where is this pointing at? So this being a 2 is going to make this an 8 and a 4. That's bad, isn't it? Oh, I can't have oh, no, I could have a 4 here because the 4 here isn't activating anything. Oh, right. Okay, FGM points out, if I make this 2-1, I've also burned my activations because I've used 2 cells to activate this one. Very good spot to FGM there. So this can't be 2-1. So this is not the 1, and therefore I believe this is a 4. And I think we get to bring out Zach for our Digidance. Lately has really been a heavy 4 meta for setters. Thank you, Zach. Thank you very much. Much appreciated. I know you've had to do a lot of 4s lately. I don't know what's going on with setters and 4s, but that seems to be what is happening. Okay, so this 4 immediately activates this cell. I think we're probably going to have to start, like, Xing things where we know where that cell is activated from. But I'm not sure. Funnily enough, this cell is a 2 from this direction and an 8 from this direction. And so if this cell is an 8... Oh, I should just look at my own pencil marks rather than talking. One of these 2 is a 1, and therefore they're a 1-2 pair. How about that? And so those being a 1-2 pair make this an 8. So now one of these now is the 9 down here, looking up at this. This isn't a 2 anymore. The 8 there is activating this cell. I'm going to like throw in a red flash there to indicate that I know where that one is activated from. I can do the same over here. I guess also here while I'm at it. And so therefore this can't be the 1 because this is activated by the 8. And so therefore this is the 2. And that's the 1. It activates itself. And so with here activating that. Okay, so one of... Sorry, did I screw up the 9 pencil mark? I removed the wrong 9 pencil marks. I absolutely removed the wrong 9 pencil marks. Oops. And then I put them back in the wrong place just to maximize the chances of disaster. So this can't be a 3. This can only be a 9, which is activating that. Which now means that this has to be the one that's activated by this 9 down here. And so that is activated by that. This 2 activates this cell, and we know where it's activated from. Alrighty. So these are either 1-2 or 3-6. I might as well pencil mark just by magic. So we've got that. Let's see. Okay, so... Oh, right. FGM points out this 9 activates this cell. So let's go ahead and mark that. I guess it doesn't even... Is there any reason for me to even mark activated cells that aren't on black dots? I don't think so, right? I can just only mark I think so. Unless someone tells me otherwise, I think I don't need to mark activated cells that aren't on black dots. I don't think it's ever worth it. Okay, so where are these two cells activated from is the question. Neither of them can be activated from the column, and so these both have to be activated from the row. So this could never be a 1-2, because if these were a 1-2, I would need a 2 here, and I can't have two 2s in the box, because they would have to be activated from this side, because I can only have 1 8, and so I have to have 1 8 over here and 1 2 over here to activate these, but that means this isn't a 1-2, it's a 3-6, is the upshot of that. Okay. Sorry if I did not articulate that well. These need to be activated by the rows, not by the column, because the column is already used. And so in order to get one in the row, I need a 2 on this side, and then I need to get an 8 on this side, because I can't make both of these 2s, is the point. Okay, so let's go ahead and pencil mark these. 3, 4, 5, 6, 7, 8, 9. Okay. And then let's look at, per ranks, let's look at this column where I need to now activate all 4 of these cells somehow. So again, I need to activate 1 from above, 1 from below, and 2 from the sides. So that is very interesting. So what I'm saying is this cell can't be 5 or 6 because it wouldn't activate anything. This cell can only be 3 or 7. And this cell down here can only be, and let's write this in, 2 or 3, or 7 or 8. And maybe one of those is like obviously dumb. I'm not sure though, maybe not. And then I know that, well, it's not there. So somewhere, so one of these has to be a 4, because I can't put the 4 over there. So one of these two is a 4. So one of these is activating one of those. And then somewhere in one of these is a 6. I'm going to pencil mark that across boxes, but try not to get too confused by it myself. But one of these has to be a 6 to activate one of these cells from the side. Okay. So we've got that. Okay. I see that chat has lots of other things, but I wanted to do all the pencil marking from this ranks point first. And then we can look at chat's thing. Okay, so Philippe's point is that this cell has to be a 3 because we can't activate these two cells from rows, I'm being told. So I could not activate... I could not use a 4 over here. I could use a 6 over here to activate one of these, right? I feel like I could use a 6 over here to activate one of these. So I think one of these needs to be handled by the column, but I don't think both of them need to be handled by the column. Let's see. Over here, let's see, people are interested in this. So this dot is either a 4-8 or a 3-6. That's certainly true. So is the question where I'm getting all of these things from? So these are in column 8, so I can't put another 8 over here. So these two can only be lit from this side and the bottom. And this one can't be lit from the bottom either. So therefore that one has to be lit from the bottom. So I think what I'm saying is that this cell is a 3. I think this is getting at... I think this is ultimately the point of what was stated by Jim. I think this is Jim's point. And so now this has to be lit, and the only place it can be lit from is here. So therefore, this is a 2, lighting that cell. Like that. So this is not a 3. Okay, now I'm going to get rid of these 6 pencil marks, because now they're really going to confuse me if I don't pay close attention. Okay. So, what did that do for me? Let's see. Yeah, I've already taken care of those, right? For these, actually, these I could even light from the column without any problem, I don't think. Let's see. Garion says if this is a 7. Ah, wow, yes, that's awesome, Garion. If this is a 7, this is a 3, and they both point at this cell. But that's too many things pointing at this cell, because I only have 4 things that can point at stuff in this column. So this is not a 7. This is only a 2 or an 8. So it's either lighting that one or that one. And this is a 3 or a 7, so it's only lighting that one or that one. I do have a Jovi on 4s, which is very interesting, because those 4s align, which pushes a 4 down here and tells me that these dots are actually known. These dots are a 1, 2, 3, 6. Those are the only dots I can make without a 4. And so, therefore, this is an 8, which activates that cell. Okay. This is a 3 or a 7. Of note, these can't be 3, 6, can they? I don't think these can be 3, 6. If these were 3, 6, this box has too many 3, 5, 6, 7s in it. So this dot, because this dot can't be 3, 6, this dot has to be from 1, 2, 4, 8, but there's already an 8 in the column. So this is just from 1, 2, 4. So therefore, this can't be the 1, 2 one, because that would be a 1, 2, 4 triple in the column. So this is the 3, 6 one. This is the 1, 2 one. These are from 1, 2, 4. There's definitely a 2 in there, for whatever that is worth. So these... Oh, these can be lit from a 7 above. Oh, yes, the 3, 6 looks up and makes this a 7. I was trying to prove that wasn't a 7, which would have been a big problem. The 3, 6 made this made this not a 3, so that's a 7. Okay, so now I have lit this. Now I have to be super careful, because I need to light both of these, and I can do it neither from below, which would require these to be 3s, or above, which would require these to be 7s. So I have to light both of these from the row. And so this one needs to be a 5 or a 6, and this one needs to be, well, it's not a 4, because there's a 4 in the box. So this one has to be the 5, which means this has to be a 6. Which means that's a 3 and a 6. Ooh, we've got the setter in the house. Hey, Rocky, this is a very cool idea for a rule set, by the way. So that does indeed handle both of those. To make sure we've got that. Okay, so these two need to both be lit by the sides. This one can't be lit from that side, so it's got to be lit from that side, making this a 4. Making this an 8 and a 4. And this one needs to be lit either from, well, it's not being lit from there, so this one needs to be lit from over here, where this needs to be a 6. making that a 3 and a 6. And making that a 5. Making those a 3 and a 6. Oh, I should actually light the thing that got lit. Okay. So I had 8s pencil marked over here. The 8s were for saying I need to highlight one of these. Now that has to highlight it from there, making that activated. Now the 2 can't also activate that, or it would double activate. So that's a 2. Oops. And that's activated. And so now this is the 2 for the black dot. This is a 1 or a 4. And we've got all kinds of stuff happening. Okay, so these cells, let's look at them, are a 1, 2, 3, 4, 5, 6, 7, and a 9. Okay, that does not give me a lot of insight into what's going on in this black dot, does it? Okay. So. Good point. From Mario. This cell is activated because of that 5. I just did not actually mark it. Okay, so this cell doesn't need to be activated anymore. This cell does need to be activated still, and it can't be activated from below. So it's either activated by a 3 here or by a 7 over there. Garion makes up a point that I can just place the 3 in this box in a very betting tree friendly manner. So these are therefore from 1, 2, 4, 8. Noted. And so the 6 in column 3 is placed there, meaning that these are from 1, 2, 4, 8. And that one's not a 1, at the very least. I know the 6 in this column is in one of these 2 cells. I should just go ahead and mark that. 9 in row 7, Jim points out the 9 in row 7 goes there. This is a triple that I should fill in of 1, 2, 3, 4. Oh, the 1, I just know where it is. The 1 just goes there. 2, 3, 4, 5, 6, and 7. And so I know the order of those too. So this box is just done. This triple is done, and notably includes a 4, which is going to be very helpful, and a 3, and a 7. So this isn't a 4. So this is only 2 or 8. So this is only 1 or 4, because of the way magic works. I suppose I know that this has got to be 4, 8, I think, if I use uniqueness, but I'm not going to do that. But it seems likely. Row 4, column 7. Yes, this is activated below by the 6. Okay, let's see. Ambrose is asking where this cell's activated from. So not from above, where it would need to be a 4. Not from below, where it would need to be a 6. So it could be activated from this side, where that would be a 4. And not... Oh, that's the only way, because from this side it would need to be a 6. So actually, that's the only way. This is the only cell that can activate this. Good spot to Ambrose. So that's a 1 and a 2, and a 2 and a 1. Some 4s over there. So those are a 3, 7. This is a quad of 3, 4, 5, 6, 7. Okay, well, neither of those are 3, 4, so neither of these are 5 or 7, and that is a 4 and a 3, and that's a 1. That's not a 1. So these are a pair now. 5 and 8 is what seems to go in those 2 cells. These are a triple, which is always helpful in a box with a black dot. 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so there's no 4 on this, and it's not 1, 2, so therefore this is 3, 6. This is going to give me what looks like a deadly pattern, but it's not going to be a deadly pattern because of the activating. That's really cool. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Those aren't 2, so that one better be. Those are a 7-8 pair. This is a quad as well. 3, 4, 5, 6, 7, 8, 9. Those aren't 4. Those aren't 8. This seems not to be a 2, so that can't be a 1. Let's see. Let's just fill in this triple. Why not? We're basically full pencil marking the grid anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is not 1 or 6. This is 7 or 9. This isn't a 6. Oh, this isn't a 6 because of the 3-6 pair. So if I believe my pencil marks, this is a 6. And I should, in this case, believe my pencil marks. This is a 6 and it's placed. There's a 3-7 pair there. So that's actually not a 7. So that's a 9, making that a 5. See, and I bet you doubted I would get anywhere by gratuitously pencil marking everything. That 3-7 makes that a 1. But we have gotten somewhere by gratuitously pencil marking everything. Ooh, a directionary puzzle on Simon today. Excellent. Congratulations, directionary. Big congrats. Greatly appreciated. 3-6 does resolve the 3-7, Andrew says, so that's a 7 and a 3. These are 3. Well, that one's 3, I should just say. And so this is 7 or 8. I don't know which. Let's see. These are a pair of 7 and 8 as well. I should look at. Oh, in this column, the 4 is definitely on the dot. Because if I just look at it, I can't put the 4 down here, and I can't put the 4 up here. So the 4 is on the dot, and so if the 4 is on the dot, the 1 sure isn't. So this is either a 4-2 or a 4-8, for whatever that is worth. That was a great bonus Tall Cat video the other day, Eric. Tall Cat made this very cool cave puzzle that was featured as a bonus for cracking the cryptic patrons the other day. It was very cool. So these are a 5-9. These are a 4-7. Let's see. These are a 2 and 4. Oh, the 2. There are 2, and the 2 goes there. My computer reminding me I should turn my speaker off. 2, 3, 4. That's a 5. That 2 looks up and does make this a 4-8, which makes that a 7 and an 8 and a 9 and a 1 and a 7 and a 7 and an 8 and a 7 and a 5 and an 8 and a 7 and a 5. Is it genuinely true that this cell is unlit? No, it's not, because this 7 lights it. Let's see. This is a 9 and a 5 and a 4 and a 7 and a 9 and a 4. Okay, is it genuinely true that these are unlit? Let's see. This, oh, either of these, interestingly, could be lit from above. So one of them is lit from above, definitely. Neither of them is lit by the 7. Oh, the other probably is going to have to be lit from below, because if it was lit by the side, then this would have to be a 5 or a 6, and it can be neither. So, right, so one of these is lit by that already. This one can only be lit by that cell, making this a 6, which lets us do our lighting dance. Thank you, Zach. I appreciated the little bit of like jazz tap that you put in to reference the 4 dance from earlier. Very nice. So we get all of those digits sort of flowing in. We can mark the remaining cells going 9, 1, 5, 2, 4, 9, 8, 5, 8, 4, 2. I arguably could have asked for Mark's help a little bit earlier. And the betting tree works out to be a 1. So congratulations from Zach and I to all the 1 bettors out there. May all your betting tree wishes come true. Very cool thing. I love the mark pop-up. The mark pop-up is so cool. Mark just has so much personality that comes through in the things he does, and I just love it. Yeah, that was very interesting. Yeah, I'm trying to decide. I bet I bet even Rocky has done other things with the activated cell thing, but that was a cool idea. I liked the use of all of the cells on black dots are activated was a cool way to sort of introduce it. Very neat. I'm sure someone will make a killer puzzle where only the killer cages only sum the activated cells. That sounds like an absolute nightmare. I am definitely not setting that. But someone will make it. And then Jay Dyer will make one where the activated cells count as negative in the killer cages or something like that. I can see it all flashing before my eyes already. But anyway, yeah, I bet there are many more from Rocky on LMD. Rocky is a very prolific setter who sets very cool puzzles. The last few Rocky puzzles we've done on stream have all been really cool. Alrighty. Well, I'm going to take a quick break. Please do take a second to thumb the stream if you have not. Just click the little thumb button to give it a like. YouTube likes and helps other people find the stream. Much appreciated. I'm going to go dig up a puzzle, search my likes for a minute, and we'll be back shortly. Alrighty, welcome back. I'm sure everyone will be shocked to see this Jay Dyer puzzle. So I originally thought that this was the most voted on puzzle, but because of this weird ongoing Discord bug with displaying votes, this is the second most voted on puzzle. But anyway, I'll tell you the supporters who voted for it anyway, just because I already wrote their names down, so I might as well. So this puzzle was voted for by Doomdiat, Luda, Russ, Jay, Directionary, Math Pesto, and David. Thank you all so much for your ongoing support. It is greatly appreciated. So let us read the rules for Jay's puzzle. So we have normal Sudoku rules. Digits in a killer cage cannot repeat, and they sum to the clue at the top left corner. And then we have standard doubler rules. And so one of every row, column, and box is a doubler, and the double cells count as double in cage sums. So note the way that Jay has sort of squared this this circle. You have to do a slightly weird decision of whether or not your killer cage is allowed to have this happen, where this would be a double 4 and an 8, because double 4 and 8 have the same value. That's okay. Jay has made very clear it's the digits that can't repeat, not the values, which is a slightly weird. It's the annoying thing about doublers and killer that you have to like really think about this. And I tried very hard not to think about it, and I thought I understood it until Memerister made me think about it more, and then I just got confused. So anyway, but that's the rules for this puzzle, so I understand how this puzzle works. Let's see. Not all doublers are necessarily in cages. It does not say that I can't repeat doublers in cages, I don't think. Someone who can skim text better than me, tell me if it does actually somewhere tell me I can't repeat doublers and cages, but I don't think it tells me that. Let's see, we'll go ahead and throw a bedding tree down here, although if Jay is around, she often is, she might request a bedding tree locomotion. So there we go. Actually, I don't think in this... Yeah, there have to be repeated, yes. There have to be repeated doublers in the 60 cage, because I can't get to 60 with only one doubler. So yes, so we've got lots of cages going on where there obviously has to be a doubler inside the cage. So all of these cages sort of around the ring, these are all cages that need at least one doubler in them. I'm going to highlight these in yellow just for a second. So these cages all need at least one doubler, and 2 of them need 2 doublers, because the 60 needs a second doubler, and the 55 needs a second doubler. So between these cages, we need a total of 6 doublers. And so my question is, what's the smallest covering set for this? Yep. Oh, no, it's not. It's not, I don't think. Can I cover this in 6 houses? I thought for sure what I was going to get was that there was a covering set for this collection of cells that was 6 houses in size. But I don't think there is one. Like, I could use this box. Okay, so if I use this box, yeah, this is not quite going to get me there. Oops. Because this is using 5 houses, I believe. Oh, I just missed... Yeah, I don't think, unfortunately, that I get to do that unless I am missing some easy covering set for these. If you're trying to understand what I'm doing, by the way, very often in puzzles of this sort, where you need a bunch of specific sorts of digits sort of floating around in places. Oh, maybe I need more than 6. I bet I can prove I need 7 or something like that if I actually look at the math. I'll look at it in a second. But if you can actually come up with, say, this row and this column need to have 2 9s in them, for example, then what you learn is, this cell could never be a 9. That is the kind of thing that you do. Oh, that's a very interesting idea. Although I'm not sure... I'm now trying to decide how this is going to work, given that there's doublers involved. And I admit I have not thought a great deal about how doublers interact with the Fistamafel ring. But Andrew is pointing out that... I don't think I can do doublers with the Fistamafel ring in any particularly nice way, but I could be wrong. Okay, let's see. Okay, so Garion says, if you do the math, I need to get at least plus 44 from doublers in these cages. So 987654 is... well, not going to get me to 44. So actually, Garion's point is that if I actually add all of these up, and I'm going to do this math in a second, Garion's point is I actually need 8 doublers in these yellow cages, which is certainly I can cover this in 8. I think 8 is exactly the number I need. 1, 2, 3, 4, 5, 6, 7, 8. Yes, okay. So, I guess it's very easy to see. It's these 2 rows, these 2 rows, these 2 columns, and these 2 columns. So let's get to where this plus 44 number is coming from. So because this is going to be huge. I really love covering set logic, by the way. It is one of my favorite things. You'll notice this shows up a lot in my puzzles. So what's going on here is that if I total 53, 60, 52, and 55, then I get some number that I'm going to try and do. So that's 115 plus 105 is 220. And so if I don't count the doublers, then since these are each at most 44, I get 220 minus 4 times 44, which is 220 minus 176, which is 44. And so I indeed need the doublers in these cells to make up that difference of 44. And every doubler just amounts to counting that number one extra time. So for example, if I double a 9, then what happens is that if I double a 9, then if I double a 9, that adds 9 to the total. That's the point. So this means lots of things. First of all, to try and... first of all, it definitely means there's no doubled 1, or indeed no 1 of any kind in any of these cages. But it also means that none of these cells are doublers, because these cells would all double count. So none of those things are doublers. And indeed, every single cell that is a doubler in here needs to be this. So I need to figure out how I'm going to color this so that I actually know this. So, sorry, I probably should be shading the cells that can't be doublers rather than the cells that can be doublers, or something like that. Yeah, none of the highlighted white cells are doublers. That's why I'm realizing I probably want to be highlighting the opposite. Okay, I don't know an easy way to do this, but I'm not allowed to throw any stray doublers in here. So I'm going to take... Oops, that. Yeah, so let's take this. So let's highlight my collection. And so these are the cells that I'm talking about. I'm going to throw gray down over them. Maybe gray is a bad color, or maybe I want the lighter gray. That's terrible. I don't want it. Okay, so the blue cells have 8 doublers in them. And so in particular, these cells can never be doublers. Sorry, let me go back to the highlighting. Oops. Okay, these cells, and these cells can never be doublers. So I'm going to mark can never be doublers by making them gray. And no cell that is blue but is not in a cage can be a doubler, because the cages actually all need to have doublers. So none of these cells can be doublers. And so now I think the point is that I can get rid of blue, and I think I've now marked not doublers in all the cells that I wanted to mark not doublers in. So I think all of the cells that I now know are not doublers are gray. And I might be able to cover this in 8 sets in a different way, in which case we'll do that. So yeah, so the question is what yellow means. Yellow is just my way of keeping track of this set. Yellow doesn't mean doublers in this case. It just means that I know that one of those is a doubler. Hey, Codec. So now all of that is very interesting, and I'm sure it did something, but if I'm completely honest, I have absolutely no idea what it did. I do think I will make my life easier if I take Rank's suggestion of just de-yellowifying those. So So the question is, are there any of these cells that I now know are doublers? And I think the answer is no, but I could be wrong. I do know none of these is the one doubler, for whatever that's worth. I probably should be able to place the one doubler. Right? Maybe, possibly. So I've got lots of cells I know aren't doublers, for example. Yeah, so I should remember, because I completely forgot about this, 1 goes in absolutely none of these large cages. So also, just nowhere in these cages can be a 1 at all. And so, for example, the 1 in this column goes in one of these cells. The 1 in this column goes in one of these cells, and so on. Does that do me any good? And I do need to actually put a double 1 somewhere. Good point. Wait, why can't a 1 go in a 5-cell 34 cage? I don't know that there's not a doubler in this cage, do I? Oh, I do. Because if there's a doubler in this cage, it's a doubled 1, and I can't put a doubled 1 in a 34 cage. That's why. Because the only doubler I have left in the entire world is a doubled 1. Okay. So, I was thinking I had other doublers, but I don't have any other doublers. I've used all 8 of them in the yellow cells. So none of these are doubled, and none of these are doubled, because of the fact that the only doubler I have left is a doubled 1. So I've got that, which is also interesting. Some sort of skyscraper thing going on in here. That is making me uneasy. So the 1 in this box only goes in one of these 2 places. The 1 in this box only goes in one of these 2 places. So we've got this sort of very weird shape on 1s that I don't think is anything. But might be, who knows. One is placed in column 7. Oh yeah, 1 is just placed in column 7. That's the smart thing to do. Okay, so Garian notices that in column 7, actually, if I look at all the places, that's the region where I can actually place the 1. Thank you, Garian. We get to bring out Zach for the 1 dance. Ba-doop-ba-doop, woo! Ba-doop-ba-doop-boo-boo-ba-boo! Ba-da-ba-ba-ba-da-ba-da-ba-da-boo! Ba-da-ba-da-ba-da-ba-boo! Thank you, Zach. Thank you. Always appreciate the style you bring around. So now the funny thing is, as soon as that's a 1, I know these aren't doublers. Because the only doubler left that's not in yellow is a 1. And so now this isn't a doubler because of that. And so this is our first cell that actually is officially a doubler. This cell is a real, authentic doubler. And so because this is a real, authentic doubler, because I need a doubler for this box, and that's now the only place it can go, this is not a doubler. So I'm just going to de-yellowify it, and we're just going to remember I need 8 doublers in yellow. This is not that. This is not a doubler anymore. Let's see. So we actually have an authentic, genuine doubler that we can maybe do something with, possibly, maybe. So Garian's point is that I know these are the only cells that can be 1 in box 2 because I can't put 1 in any of these cages and there's a 1 there. And so that looks over here and says that one of these 3 cells is a 1, but that one's not. So one of these 2 cells is a 1. And so the fact that one of these is a 1 tells me that neither of these is doubled, which tells me that this is an authentic doubler. I like the mustard ketchup theme for authentic doubler. So this isn't a doubler, and this isn't a doubler. So we've got that going on. Do I know anything about where the 1 is going in this column? I guess the 1 in this column is going down in this box, right? One of those 2 is a 1. And whichever of these is a 1 certainly means none of these are doubled, because, again, the doubled cell is a doubled 1. So none of those are doubled. I have no idea which of them is the 1. Garian knows which of these is the 1, but I don't know yet. But that does mean that this is a real doubler, which means that these aren't. This isn't. And this isn't. So getting further progress. And so Garian's point now I understand is that if I put the 1 here, then the minimum sum of these cells is 20, and 20 is too much. So in fact, Garian's point is I can't put the 1 outside of the 16 cage. That has to be a 1, which means that's not a 1, which means that's a 1, which means this cell isn't a doubler. I guess I knew that as soon as I had that one, actually, which means this cell is a real doubler. And so that cell being a real doubler means that these aren't doublers. Means that this is not a doubler. So we've got that going on. So that is all very interesting. We're slowly piecing together our 1s. I know the 1 over here is going over there. Are there more places I can meaningfully pencil mark 1s? Let's see. Oh, the bet tree is not a doubler, right. Garian sees this. I should have seen it when I was seeing it over here. This being a 1 means that this can't be a doubler, because if it was a doubler, then it would have to be 1, because 1 is the only doubler outside of the cages. So this, therefore, is the doubler for row 9. And as soon as that's the doubler for row 9, this is no longer a doubler. I am sure there was a sane way to color this puzzle that did not involve ketchup and mustard and there was blue in there at some point and all kinds of stuff. I hope it was somewhat coherent what was happening with the covering set logic going on in this puzzle. So let's see. So the claim is I can't fit 3 doublers into the 52 cage because I could double 2, 3, and 4, but even doubling 2, 3, and 4 gets me to 44 plus 9, which is 53. Yeah, that's perfect. Yep. So if I put 3 doublers in this cage, the minimum sum is 53. Which is conveniently 1 more than 52. That is gorgeous setting. So therefore that is not a doubler. And so therefore the doubler for row 6 is there. So therefore this is not a doubler. Let's see. Okay, so now the 55 cage has 2 doublers in it. But the 55 cage, I kind of suspect, could accommodate 3 doublers. Actually, can the 60 cage have only 2 doublers? It can, right? And 8 and a 9 and an 8 would be 17. Plus 44, I think would work. Let's see. Right. Okay. If this cell is a doubler, Andrew's point is that would rule both of those out from being doublers, and the 60 cage would only have one doubler. But we know the 60 cage has at least 2 doublers. So this can never be a doubler. And so that means the doubler in column 5 is in one of these 2 cells, and therefore this is not a doubler. And therefore the doubler in column 6 is there. Or if you prefer Rank's way, the doubler in row 1 is there. So now one of these 2 is a doubler, and one of these 2 is a doubler. Let's see, 53, I can just get to with only one doubler. That's suspicious. Because if I double a 9, then I'm fine in the 53 cage. In fact, it's exactly correct. Let's see. Okay, so I'm reading Carl's point here that Carl says this has to be a doubler, because if this isn't a doubler, then we know that these are a 7 and a 9. But this being a 9 or a 7 would maybe break this 34 cage. It would, because I need a 7 and a 9 in here, and so I can't have these be a 7-9 pair. So therefore this is a doubler. And therefore this is not a doubler. And therefore this is the doubled 1. And this is not a doubler. So there is the doubled 1. I love that it's totally set up to make you think that this might be the doubled 1, and then it turns out not to be. So that, by pencil marks, placed a 1 there as well. I know what these digits are. I probably should go ahead and mention 2, 3, 4, 6. I've had that happen many times, Jay, that I thought I knew how a puzzle was going to resolve, but it did not. So this is a 9, as is being pointed out. Like I said before, if there's only one doubler in here, it actually works out perfectly if that's a 9. So that's a 9, which now probably tells me what the 30 cage is, because now the 30 cage doesn't have a 9. So now the 30 cage is known. So now the 30 cage is 4, 5, 6, 7, 8. And so now these 2 cells are a 2, 3 pair. Intriguing. I don't know if it's actually intriguing. It might be nothing at all. Hey, Rockrat! So, oh, this cage could have its 9 there. That's annoying. Yes, whereas 9 in box 7, Garion points out, the 9 in box 7 can only go here, because remember, I can't... Did I unfreeze? Woo, I'm back. Excellent. Excellent. All right. So we are continuing to fill this in now that I have returned. So these 2 doublers, they need to sum to 7. And so what do these sum to 7 as? It's either as 2, 5, or 3, 4, but it can't be 3, 4. That's cute. So these two need to sum to 7, and it can't be as 1, 6, because this 1 sees both of them. And it can't be as 3, 4, because this cell can be neither. So it's 2, 5, and we know the order. It's 5 and 2, like that. Uh-oh, I'm told they sum to 8. No, they sum to 8. Gosh darn it. Well, it's not 1, 7, and it's not 2, 6. So actually, the argument still works. I just need to do it correctly. They are 3 and 5, and that one can't be the 3. So that's the 5, and that's the 3. So it still works, even though I tried to break the puzzle. These cells are a pair, which consists of 2, 3, 4, 5, 6, 7, 8 is what goes there. So that cell's not a 7 or an 8. For whatever limited thing that's about. Okay, so these two digits need to sum to 11 without being 3, 8 or 5, 6 or 2, 9. Wait, didn't I just say all the ways to make 11? I feel like I said all the ways to make 11. Not 2, 9. Not 3, 8. Oh, 4, 7. I'm missing 4, 7. Okay. These are a 4, 7 pair. Okay, and so therefore we know that these as a triple are 2, 3, 4, no, not 4, 5, 6, not 7, and 8. These are 2, 6, 8 is what goes into these cells. And so therefore... excellent. 2, 6, and 8 add to 16, which is apparently what they're supposed to add to. Is there a way this 33 cage doesn't have a 7 in it? No, there is not. Because the 33 cage, if I look at my calculator, always has a 7, so therefore this is the 4 and that's the 7. So no 4 over there. What about the 34 cage? The 34 cage always has a 6 and an 8 in it, so this is always the 2. Therefore, neither of these are 2. I appreciate that the doubler thing seems to be working with Sven, so that's a 3 and a 2. Neither of these is a 2. Okay. So... Screaming Ice Cube says these cells sum to 38, so therefore these two cells sum to 7, but they're not 1, 6 or 3, 4, so these are 2, 5, and they can only go in that order. So remember that these are 4, 6, 7, 8, 9, and so therefore these digits are 3, 5, 6, 7, 8, 9. Okay, so these are 3, 5, and so Carl's point is that's the 5 and that's the 3. So no 9s over there, no 7s over there. Hey, Glum Hippo, how are you doing? I hope you are having a good holiday season. I need to find a way to squeeze a 6, 8 pair into this row somehow. Sadly, there's annoyingly a couple places I can put them. 3 in box 9 is just placed. 3 in box 9 is there. Which makes these 6, 7, 8, 9. Ooh, we get a donation from Glum Hippo with the important message. Don't forget to like the stream. Or don't forget to like the stream. I guess I'm supposed to stretch out the M. I'm not quite sure how to do that. But thank you very much, Glum Hippo. Greatly appreciated. And a great message that we should all consider this holiday season. And let's get you a donation dance from the donation dancer himself. Woohoo! Thank you, Zach. Thank you. Much appreciated. And thank you very much to Glum Hippo. Always appreciated that. So that's a 2, a 4, and a 3. No 9 over there. This isn't 6 or 7. That's not 7. These aren't 6. That's not 5. These aren't 4. Let's see. I have a quad in column 9, points out Glum Hippo. I do have a quad in column 9. Good spot. So these digits are a 2 and something else. Not a 3. 4, 5, 6, and no? Oh, and a 1. It's a 2 and a 1. Therefore, that's the 2 and that's the 1. I do recall earlier that someone said I could place the 1 someplace or another. I bet it was that 1 that I could place earlier. And then got distracted and didn't do it, as is the story of my life. Let's see. This is a lovely design. Covering puzzles always delight me. 2, 3, 4, 5, 6, 7, 8, 9 are the digits that this cage needs. So these aren't 3. That's not a 9. That's not a 4 or a 7, actually. So the break-in here is the fact that you can cover these cages, which need 8 doubler cells. You can cover them with 8 houses. And so then you get lots of eliminations, because then in those 8 houses, every doubler in those 8 houses has to be in the cages. That's what I mean by covering puzzle. Because I think the term that Ransk taught me is covering set, for a collection of houses that cover a collection of cells. Okay. In box 4, I'm being told we have a 3-9 pair. Let's see. Neither of those is, or none of those are 3. This just is, no, this is not 3, sorry. One of these 2 is 3, though. Box 4. In box 4, these cells are 3 and 9. Because I can't repeat the 3 and 9 in the cage. These cells are 2, 3, 4, 5, 6, 7, 8, and 9. I somehow missed that this was also 2, 4, 5, 6. That one's not a 5. This one's not a 2. That almost does something, but not quite. 3 in row 4, I am being told I can place. It's not in any of these places. Okay, it's not in that place. Okay, how do I know? Oh, it can't be here because it would rule 3 out of this cage, and this cage needs a 3. That's a very good spot, Tyrgannus. Love that. Another of my guilty pleasure deductions. Okay, so one of these is a 9, meaning that that's not a 9. Let's see. These are 6, 7, 8, 9. Those aren't 7, for whatever that's worth. Let's see. 3 in the 55 cage, Garion says, is placed. I had to find the 55 cage, but 3 in the 55 cage indeed goes not there. Try again, Zeta. Oh, there. I probably can get rid of the gray now. That'll make this a little easier to scan. We can pretend that that's what happened. 9 and 3. No one will know. Not a 9. So we've got all of that. See, Screaming Ice Cube asks where 5 is in the 55 cage. It's in one of those 2, but not in the one that's in a row with a 5. So now this is a 6, 8, or 9. Interesting. if it's a 6 or 8, it's the other 6, 8. I probably should be able to do some sort of geometry with this 6, 8, 9. I know one of these two is a 9, so I know that cell's not a 9. That doesn't seem likely to be a very useful deduction, but it's true. Let's see. The 2 and the 53 cage can't go in either of those places. Can't go there by the row, and can't go there. Oh, yeah, the 2 and the 55 cage is displaced. Good spot to Carl. I tried to place it. What did I do? Oh, I'm in pen mode somehow. Oops. No. Okay, there we go. This just is the 2. Okay. I don't know how I ended up in pen mode. I'm sure it was my fault, but I don't know what I did. Now in the 52 cage. Not in any of this. Ah, yeah, now in the 52 cage. Now it goes there. Very nice. Garion asks where 4 is in row 7, and the answer is it's definitely in one of these two cells, so aka definitely in this cage, and so therefore that can't be a 4, it would be a second 4 in the cage. So no 6s go there, no 6 over there. These are just a triple. 2, 3, 4, 5, 6, 7, 8, 9. Okay, they're not a triple because there's a 7, 8 there. But still, but I know the 9 in the cage is in one of these, so this is never a 9. And in fact, this cell sees all of the 4, 7, 8, 9 triples, so this cell just is a 6, which makes that an 8 and that a 9. So that is not a 6, which gives us an 8, 9 pair, which means neither of these is an 8. That 8, 9 needs to go in this quadruple, so that 8, 9 goes here in this quadruple, aka this is not a 7. This has become an 8 and a 6 by magic of remote pairs or whatever. 8 and 9. Let's see, that's a 6, 7 pair in the row, so that's not 6 or 7. This 8, 9 pair looks up, so neither of those is 8. So those are a 4, 6 pair, so this isn't 4 or 6. Let's see. Gorgeous again. This cell, Garion points out, sees this 7, 8 pair. It sees this one in the row and this one through the cage. And so because this cell sees a 7, 8 pair, it's exactly like if there were a 7, 8 pair in the row. This can't be an 8, so therefore this is a 9. That's an 8 and a 9. 7 and an 8. Alessandro asked if it's more satisfying to solve a tough puzzle or construct one. That's an interesting question. Probably for me construct, although I would say I don't construct many tough puzzles. For that matter, I don't really solve that many tough puzzles, but some of them. But I feel like either way, it's sort of about like seeing some really complicated machine come together, and that's very satisfying, whether you were the first to see the complicated machine come together or whether you're seeing something that someone else first saw. I think it works either way. So these are 1 and 5, I believe. 2, 3, 4, 5, 6, 7, 8, 9. Yes, these are 1 and 5. Actually, let's mark. Oh, why is Mark gone? Mark is hiding? Somehow my box where there's usually a picture of Mark, it's just an empty box as though Mark has gone for tea. Sven is still in the box. Hitting the mark tool still marked the cells, but somehow did not cause Mark to appear this time. I don't really know. Anyway, so that's going to let us fill in some things if we trust Mark, which of course we do. 7, 8, 4, 5. So 8 and 5 and 4. I think Tristan can put a link in the chat to where the mark tool can be found. This 7-9 pair makes that a 6. That's a 2. Because we get that question a lot, and I think Tristan has like a command or something to say where it is. But it is a creation of Chameleon, and there's a GitHub page for it that you can just click, and it will work out fairly reasonably. 5 and 1 and 5 and 1. And the betting tree is an 8. Congratulations from Zach and I to all the 8 bettors out there. May all your betting tree wishes come true. Lovely puzzle. I quite enjoyed that. Not surprised that Simon did this one. This is a very neat construction. I really love the break-in. That's the kind of Sudoku thing that I really love. Like, I really always talk about how I dislike set, but that sort of covering idea, I mean, it's really just like Jovi would call this a fish of some sort. Because we just, like, used a gigantic, complicated fish on doublers in order to figure out where doublers could and couldn't go. So it was like a generalized X-Wing, but generalized to 8 houses instead of 2. But very cool. I liked that a lot. Alrighty. I'm going to take a quick break. I will find another puzzle, and then I will be back, and we will do, that's right, another puzzle. So be right back. If you've not yet liked the stream, please take a second to click the little thumbs up button. It really helps us. And I'll be right back, and I will try and find something else in the bucket that is equally wonderful and delightful as this. But it might be difficult. I will be right back. With only a little bit of trepidation, I have pulled up this kuraban puzzle. So kuraban has this series of single constraint puzzles. And they are all amazing. I've done probably a dozen of them on stream at this point. And they are fantastic. Now, they range in difficulty. I'd say probably most of them are 2-star. Some of them are 3-star. This one is 5 stars for difficulty. So it will be interesting to figure out what is going on with this. So I'll explain exactly how the rules work. But if you're sort of newer to Sudoku, I really recommend checking out Kuraban's single constraint puzzles. I recommend checking out the 2-star ones, to be clear. But I think they're a really great starting point. And if you go back and look at some of the tutorial series I've done on sort of like intro to various standard Sudoku constraints, I almost always go to Kuraban's single constraint series. Speaking of which, Tristan, if you could double check and make sure Kuraban's Renban 4 puzzle is in the bucket. I didn't see it there, but I want to make sure I do that one too. All right, so how does a region sum line work? The way a region sum line works is that you look box by box that a line passes through. So for example, this line, all of these cells are on this line in this box, and then this passes into these. Oh, I've done all of them. Somehow I thought I was recently told that there was a new Renban series, or a new Renban by Kuraban. Maybe I was dreaming about getting to do another Renban by Kuraban. They are that good. So this line passes through these boxes, and what this is saying is the sums of each highlighted cluster are the same. So these 5 cells sum to the same as these 3 cells, sum to the same as these 5 cells. Oh, I did number 3 before it even got to LMD. That sounds like me. I remember number 3 being particularly spectacular. I'm now reminded of the fact that I owe the world a top 25 puzzles of 2022 list. I was feeling like, on the one hand, 25 puzzles is a lot to put on a top list, but on the other hand, I've streamed 3 days a week for 52 weeks. So that means I've done 150 streams, and then on the average stream, I did 3 or 4 puzzles. And so if you figure out what percentage that is to only pick 25, it's a very, very, very small percentage. So I feel like 25 is appropriate. That is my ultimate conclusion. Okay, so the thing I'm drawn to is the fact that these cells need to sum to a lot. In fact, I'm trying to decide exactly how to split this up. There was a 6x6 in my list last year, Kuraban. My favorite codec puzzle of 2021 was a 6x6 that I really loved. So I'm trying to decide exactly how I want to deal with the fact that there's 8 digits in this column. And think about, am I trying to figure out what the sum of this line is and then divide it by 3? Or am I trying to do that? Okay, so here's maybe an easy one that is much better place to start. Selena has a much better place to start than that, which is this. These cells sum to a minimum of 15. And so therefore these pairs of cells have to be from 6, 7, 8, 9. But I actually can tell you that these cells need to sum to exactly 15. Because if these cells don't sum to exactly 15, then they sum to 16 or 17. And let me show you why that goes horribly wrong. So let's say the sum is 17. That means that these are each forced to be an 8-9 pair, because there's only one way to make a sum of 17. But now where do 8 and 9 go in this box? Well, now 8 and 9 go here. And these 3 cells, those 2 plus the third one, need to sum to 0. And because this isn't a Jay Dyer puzzle, we can't do that. And if we did 16, it would work exactly the same, except with 7 and 9. So, in fact, the sum is 15, which means that these are 1, 2, 3, 4, 5. And these need to be different ways of summing to... oh, we're guessing that is the bet tree, by the way. These need to be different ways of summing to 15, which means, as Selena suggests, we get to color. Because now, where did the yellow digits go in box 5? Now the yellow digits have to go there, and the green digits have to go there. And so we get all of that. Now, it's interesting that in this box, I need to put... Oh, well, there's two... Actually, in both these, I need to be very... It's very interesting what's going on. But I think this one's actually the more interesting one, because I need to make 2 of these cells green. And if I make 2 of these green, we know they sum to 15, and then this yellow cell would be a 15, and yellow would have to be a 15-0 pair, which is a problem. So therefore, this is a green, and one of these 2 is green. Mario helped me see that while I was about to articulate a similar thing going on up here, but the thing going on up here isn't quite as good. But there's a green on one of these cells, which means the digit that goes with it has to be pretty small, because I have a green and another digit summing to yellow here. And so this yellow can only be 7, 8, 9, and I know I have a 1, 2, or a 3 to collect in here. Okay. Smart point that these 2 are the same digit, for the simple reason that that's literally what the line says, is that that cell sums to the same as that cell, so therefore this cell's definitely yellow. And is therefore 7, 8, or 9. This can't be the green digit, I don't think. Maybe it can. It might be able to be the green digit, actually. I was just looking at these 2, and whether these 2 could sum to a yellow and a green and yet another digit on top of that. But unknown. I should also mark, by the way, that I know that these digits are all from 1, 2, 3, 4, 5, because they see a 6, 7, 8, 9 quadruple. So I've got that. which gives me an additional proof that these don't sum to 15. This line sums to something strictly higher than 15, which I already had sort of figured out earlier in a different way. These two need to sum to a single-digit number. And this single-digit number needs to be at least 6, because it's a sum of 3 digits. So this is a 6, 7, 8, 9 here. Down here. I don't know if it's yellow or green yet. Smart point. I also have that same quad here. So these are also from 1, 2, 3, 4, 5. And we've got that. So I only get one more 1, 2, 3, 4, 5 on here. And 2 of these cells have to be yellow. Could this possibly be a 1, 2, 3, 4, 5? No. This cell has to be yellow, because otherwise the sum of these isn't big enough. Because if I make this a 1, 2, 3, 4, 5, which is the only non-yellow thing I have left in the box, the maximum sum of these is 12, but the minimum sum of these is 15. So this cell's definitely yellow. So that's one of my yellows for the box. And even... So the absolute maximum that these can sum to is, I guess, 18. So these digits never sum to more than 18. Which means they never have a 9 on them, for what it's worth. So the 9 in this box I know is down here. So could these digits have a 9 on them? Yeah, there's definitely a 1 and a 2 on the line. I believe that. Otherwise, I sum to too little. So this is putting some pressure over on this, possibly. I'm being told this digit can't be a 6. If this was a 6, it would have to be 6 with a 4, 5, making these 15. Making these a 4, 5 pair. And making these a 1, 2, 3, 4, 5, 6, which would make these 7, 8, 9, and break the row. If this is... So here's the punchline. If this is a 6, where do 7, 8, 9 go in row 1? They go here. But that breaks this. So this isn't a 6. This is a 7, 8, or 9. But I don't know if it's that 7, 8, 9 or not. As of yet. So I'd love to know if this is the other yellow or that's the other yellow. I feel like that might be helpful. I know that these two are the same yellow. Okay, so here's an interesting point. This yellow in this box only has 2 places that it can go. Is that potentially useful in some fashion? It doesn't sound at all useful, if I'm being completely honest with myself about my life choices. But I mean, it seems like the kind of thing that might be useful to know, maybe someday down the line. Let's see. Do I know if this cell is yellow or green? I don't think I do yet. I'm being told by Carl that exactly the same logic applies down here. If this was a 6, then these would have to be 1, 2, 3, 4, 5, 6. These would be 7, 8, 9. Unfortunately, they don't see a cell that's labeled 7, 8, 9, so I have to think more about what happens if these are 7, 8, 9. Why is these being 7, 8, 9 broken? It breaks box 6. Oh, right. These can't be 7, 8, 9 because the sum of all 5 of these is equal to the sum of these 3, and the sum of these 3 can't be 20 or can't be larger than 24. Got it. So similar but more advanced argument tells me that this is from 7, 8, 9. So that is interesting. And again, the maximum these sum to is 18. So again, we know that there's... Oh, this is going to be interesting, I think. We know there's a 1 and a 2 on these lines. So by fish logic, we know that one of these two cells is a 1. Who knows if that's interesting? Probably not interesting. But again, if I didn't put a 1 and a 2, then I would be a minimum of 1, 3, 4, 5, 6, which would be 19. And the maximum sum is 18. It was a great puzzle, Rocky. It was very smooth. It was very well telegraphed exactly what to look at every step, which I appreciated. So this is 6, 8, or 9. Sorry, 6, 7, or 8. This is not 9. Sorry, this is 6, 7, or 8. Ooh, there's an activated Renbon puzzle. Oh, that sounds fun. Okay, so Jay is saying that that there's a 1 or a 2 in these cells, and the reason is as follows. If these were a 3, if there was a 3 in here, it would have to be, because there's a green digit here, so it'd have to be 3 and 6, but then it would be 3 and 6 equals 9, but the 6 would be green and the 9 would be yellow, so that doesn't work at all. So so the little baby digit on this line is a 1 or a 2. I don't know a fantastic way to write that. I guess I could write it by pencil marking 3 into these cells, which I don't feel great about if I'm being completely honest, but what are you going to do? So yeah, there's a little 2. I suppose I could write it like this. Well, it's not a 9. Oh, can it just not be a 6 at all for that reason? No, it could. Right, I want it to be 2 different things. Yes, I want the sum to be a different color than the 6, 7, 8. Because one of them is yellow and one of them is green. So the thing I can't do is put 7 with 1, for example. Because if I put 7 with 1, I end up with the same problem. Green plus 3 equals 9 has the problem that it makes it makes 6 green and 9 yellow, but 6 and 9 are the same color because they add to 15. Which is a very clever and cute point that Jay discovered. So these 1s and 2s running around the outside, and things like the fact that I know there's a 1 in one of these 2 cells, is getting kind of interesting in terms of these. Like, this sum has to be pretty large. So maybe I want to figure out what the absolute minimum this sum can be. So that was the sort of thing I wanted to start with, but let's do it now. So these cells sum to a minimum of 36. Plus 6 is 42. Plus 3 is 45. Okay, well, that was terrible. These cells sum to a minimum of 45, so the sum is at least 15. But I already know the sum is more than 15 because of this cell. So that was a very, we'll say, heartbreaking version of this. Okay. Here's maybe this is the trick. Whatever this digit is, I'm going to make it purple. It needs to show up in either that L or this L. And so what that means is that these two cells here are the sum of the other 4 digits that show up, because you have purple plus these two equals purple plus 4 other digits. So these two need to sum to at least 10, is maybe interesting. So, like, even if this is a 9, these still need to sum to at least 10. But I'm not quite sure. I feel like that's an important observation, but maybe it's not important yet. I can't quite figure out how to use it as of yet. I'm also worried I'm supposed to combine these two lines and, like, minimize this going through this box. That sounds like a lot of work, though. I don't think kuraban would make me do that. Right. Okay. So here's a good spot from Medi. I can't put 9 on this line for exactly the same reason. So there's a 9 there. And that does many things. One of which is to drop a 9 on this line by Jovi Wing logic, because my 9s in columns 2 and 3 have been burned by boxes 1 and 7. So my 9 goes over there. But also, I have a Jovi Wing, I don't know where, but one of these is a Jovi Wing on 9s. And what that means is that one of these two cells is a 9, which is, again, not the biggest deduction in the world. But one of these two, in fact, actually is a 9. I guess I already knew that because neither of them is a 6. So never mind. That is not an interesting deduction. I mean, it's interesting, but it's not something that was unforeseen. But yeah, one of these two is a 9. The other is a 7, 8. Is it interesting to ask where the 6 does go in this column? Is there something that goes horribly wrong if I try and put the 6 in one of those? Oh, sorry. I did not do my Jovi Wings correctly. The Jovi Wings I highlighted force a 9 either up there or down here. So what they're actually saying is that the 9 is in one of these places. And what that means is that this sum is now at least 19 at a minimum. So we're slowly getting up there, because these now have to sum to at least 19, because even if I put a 9 here, it has to be at least 9 plus 1, 2, 3, 4. Which is noteworthy. Okay, so where is the 8 in column 1 is maybe the next natural question to ask. So this given 1 tells me the 8's not here. Because if I put the 8 here, then the minimum sum of this line would be 19, which is more than 18. So the 8 in this column is in one of these. And what the fact that the 8 is in one of those means is that one of the sums actually is 18. So one of these is an 8 with a 1, 2, 3, 4. I don't know which yet, but one of them is an 8 with a 1, 2, 3, 4. And the 8 with the 1, 2, 3, 4 needs to go with a 4, a 5, and a 9. So one of these is a 4, a 5, and a 9. which is interesting. And then the other... okay, so... let's see, Garion says the other has to be 4, 5, 8. Is that because of where the 7 goes in the column? Right. The other... so now we've placed... oh, Garion just wants to do math on what the total here is. So one of these is 18. And so... interesting, because if... yeah, so... so if one of these is 18 and one of them is 17, then we have to ask ourselves, what does this column sum to? And so we could be as high as 18 plus 15 plus 12. No, I didn't do that right. So if one of these is 18 and one of them is 17, then this column 1 sums to a maximum of 18 plus 15 plus 17 minus 3, which is plus 14. 18 plus 15 plus 14 is enough, is the only thing that matters. I think it's probably easier to ask about where the 7's going to go in this column, because the 7 in this column, it either goes with a 1, 2, 3, 4 on one of these lines, which would give you the 17. But that's a really big problem, I think. Because if I do that, that means one of these lines is 1, 2, 3, 4, 8, and one of them is 1, 2, 3, 4, 7. And so now this is a 1, 2, 3, 4, 7, 8 sextuple, which means that this line is a 6, a 9, and something else. A 6, a 9, and what other digit? Oh, no, that's not... sorry, that's not a sextuple. Darn it, never mind. Sorry, I thought that was going to work, but it did not quite get me there. But if I put the 7 on the outside and the 9 on the outside, the only other option is that I put the 7 with the 9, in which case it has to go with a 7 and a 9 and a 2. So it's being pointed out that I only get 1, 1 between these 4 cells because of the given 1. And so actually my maximum, if I make these sums 17 and 18, it's actually 18 plus 18 plus 17. 18 plus 18 plus 17 is 36, 46, 53. Minus 1 is 52. Minus 2 2s is 48. Minus 1 3 is 45. And that's what it needs to be. Okay. I can now see the math. So the absolute maximum column 1 can ever sum to is 45, and that only works if these are an 8-9 pair, with these each being 4 5. And note that only worked with this being the 9 because I counted this for 18. So this is the 9, and we get to have a 9 dance. Boop boop ba doop boop boo wah! Thank you, Zach. Thank you. Much appreciated. Zach appreciated someone not having a 4 be the first digit in a puzzle for once. So green is 6 9 and yellow is 7 8. So these are not 9 or 6. These are not 8. Okay. The digit in here is green. So the digit in here that's green is definitely a 6 because the other green is there. And so this is a 1 or a 2 with a 6. I know that's not a 9 anymore. I probably can work out exactly what these are now. Because well, I guess maybe no, I can, because remember the 8 in column 1 has to go here, right? The 8 in column 1 can't go up here because then the sum would be 18, but it's too big. And the 8 can't go here because it's too big. So these digits are, in fact, I actually know 1, 2, 3, 4, 8 by our calculation from before. So this is not 8. These aren't 4 because of the 4-5 pair looking at them. So we've got that. I also know that these are all from 1, 2, 3 because in my minimization I had 1, 1, 2 2s, and a 3 here. So I know there's a 2 over here actually, just by the Jovi wing on 2s actually, because in my minimization I needed a 2 Jovi wing here, and so this sums to 18 with a 2 and a 9. And so if I sum to 18 with a 2 and a 9. Then I must be 2, 7, 9. Like that. And so therefore, there is a 6 and a 5 up here. And so 6 and 5 already add to 11. And then I need 3 more digits, therefore, that add to 6. So I do need to be 1, 2, 3, 5, 6. To be these. And so I know that these aren't 2 also, as previously noted. So let's get rid of these corner marks and fill in our tuples. So these are we've got 1, 2, 3. We need we've got 1, 2, 3, 4. We need 5, 6, 7, and 9. And here we've got 1, 2, 3. We need a 4. We've got 5, 6, and we need 7, 8, and 9. Okay. So we've got all of that going on. This is now 2. There's a 2 over here, so this can't be a 6 or a 7. This just is a 9. Because in order to make 6 or 7, I would need a 2 on the arrow, and I don't have one. So this is a 9. I'm now making a 9 with a 1, but no 2. So these have to be a 3-5 pair. That's the only way to make these sum to 9. No 9 over there. These aren't 4-5 anymore. Fun fact, this isn't 4-5 anymore because of the 4-5 in the column. These aren't 4-5 anymore because of, take your pick, the 4-5 in the box, the 4-5 in the column, whatever. This isn't 3 because of the 3 in the column. So we've got all of that. So these are a triple, which consists of 1, 2, 3, 4, 5, 6, 7, 8. These are a 4, 6, 8 triple. So that is presumably handy. Let's see. Now, yeah, I know one of these is a 3, and I know one of those is a 3, so if it's a 3 over in the other one, that's not interesting. Being pointed out, I know the 7 in row 1 is over here by Mario, and so that immediately makes that an 8, which makes that an 8, which makes that a 7. Good spot to Mario there. These I might as well fill in, I know, are 6, 9. So, and there's a 2, 3 pair here in this column, which I should have paid closer attention to, because that gives me the 5 and the 3. So that tells me that's not a 3, and that's not a 3. That is not a 5. No 3, no 5. Okay. So this needs to be a sum to 9. So it can't be 3, 6. And it can't be 1, 8. So this has to be 2 and 7. That's the only way that this sum actually works. The 7 is yellow of note. I really thought I was going to be able to get that this was yellow in some fancy way, but it did not turn out that way, at least in my solve path of this puzzle. This has to be a 1 or a 3. This is not. This is a 4 or a 5, of course. Okay. This can't be a 5 or a 6, because if this cell was a 5 or a 6... Sorry, this cell has to be a 5 or a 6. If this cell is not a 5 or a... Well, it can't be a 5, because there's a 4 or 5 pair in the row. If this cell is not a 6, then this is a 1, 2, 3, 4, 5 quintuple, and so then these cells are 6, 7, and 9. And so 6, 7, and 9 already sum to what? 6 plus 7 plus 9 is 13 is 22. Now, plus those makes it sum to at least 25. That doesn't work, so this has to be a 6. Because these sum to a maximum of 24 is the point. So that has to be a 6 in order that I can put at least 1, 1, 2, 3 over here. Now... I actually also know that there's a 9 over here. So if I actually think about it, a 7 and a 9 sum to 16. My other 3 digits, therefore, need to sum to a maximum of 8. Is the maximum actually lower than 8? I don't think so. I think the maximum actually is 8. And so if I have digits summing to a maximum of 8... they must be from 1, 2, 3, 4, 5. Doesn't quite do it for me. In any event, it definitely tells me the 6 in this box is in one of these cells, which I guess I already probably knew if I'd have paid close attention. And the other 4, 5 in this box must be in these cells, right? Because I can't put 2 4, 5s in a sum to 8, in a sum to at most 8. So these digits actually are a 4, 5, 6 triple. No. No. There's already a 4, 5 there. I'm just being silly. So I think the version, or I think the answer is I do not actually know. They do, in fact, definitely include a 1. I agree with that, to Selena. Yes. Mario pointing out that if I pay close attention, I know how to solve the equation something plus 6 equals 8. Namely, these have to be 2 and 6. So these are 1 and 3, so that's not a 1. And in fact, there's a 4, 5 pair, which has actually made this a 2. That threatens to actually be useful. That 2 looks over there, makes that not a 2. So these 2 cells are one of 3 ways to make this work. So if Auntie can see you. Anyone. I can see you. Who said that? It's like, wait, is Auntie Knight in the chat? Auntie Knight is often in the chat, but so the question is, do I know somehow these can't be 7, 8, 9? Would that break this line somehow? I don't think so, because I think the minimum sum here is... Let's see. If these are 7, 8, 9, then these would be at most 11. And then this would need to be a 1 in order to make that work, but I don't see any immediate problem with all of that. But yeah, these go with a 7 and a 9, and then a bunch of 1, 2, 3, 4, 5s. Interestingly, I know there's a 2 in one of these two cells, which presumably tells me that there doesn't necessarily have to be a 2 on this line at all, does there? I don't think there has to be. Because it could be 1, 3, 4, 7, 9. There definitely is a 1 on it. I agree with that point from earlier. Let's see. Trying to squint at where other things are happening. Like, I kind of want to mark this for candidates. Because it's a 1, 2, 3 together with a 5, 6, 7. But notice this can't be 2 or 3, so therefore this can't be 5 or 6. And this can't be 1 or 7 at all, so this can't be 1 or 7 at all. So this, therefore, is always, in fact, a 2, 3. That's always a 5, 6. I don't know if that's at all interesting, but I figured I would point it out, I guess, question mark. I know one of these two is an 8. Maybe I should ask myself, what's the absolute minimum that this line can sum to? The absolute minimum that this line can sum to is if it's a 7, 8, 9, or it's a 7, 9 with 1, 2, 3, which is 16 plus 6 is 22. So the minimum this sums to is 22. So what do I know about a sum to 22 in 3 cells? It always needs to have a 9, right? So there's always a 9 over here. And then the digits that go with the 9 have to be at least 5. So these are always from 5, 6, 7, 8, 9. That one's not 5 or 8. That one's not 7 or 8. Yeah, so it's always from 5, 6, 7, 8, 9. Ah, okay, so that's going to put a real crimp on this. Because I only get one number that's at least 5 on this line. Because I've used 4 of my 5, 6, 7, 8, 9 numbers here. And so now the maximum sum here is 10. And the maximum sum there being 10... wait, did I do that right? No, I did that wrong. What is the actual maximum sum here? It would be 8 plus 4 is 12. The maximum sum here is now 12. It's 8 and 4. Darn it, that still actually works in a variety of ways. But I certainly need to have my last 5, 6, 7, 8, 9 number on here. If I don't put a 5, 6, 7, 8, 9 number on here, then the maximum sum here is in fact 9, and this sums to more than 9. So I can be sure that these numbers are for 1, 2, 3, 4, and that one's not 2 or 3. It's only 1 or 4. Creeping up on some sort of useful oople. Yeah, the box 8 thing is what I was connecting it with. I was hoping to force this to sum to 10, but I don't think we quite got there. But I was thinking, there's only one way for this to sum to at most 10, and it's going to force everything. But that is... yeah, the 6 is too big. Somehow I was focused on the 3. The 6 is too big, because 7 plus 1 plus 6 would be 14. So in fact, we know the order goes there. Good spot to rank there. I now actually, if I pay close attention, I know that 6 in this row goes down here. Oh, I can probably do the same thing where this has to be an 8, can't I? Because if this isn't an 8, then these numbers are 6, 7, 8, which is already 21. I guess I could do 6, 7, 8 down here and 1, 2 here, and that would only be 24. Maybe that doesn't break. I bet it actually makes the total up here too big, because then I can only have 1 of 1 and 2 on here. And if I can only have 1 of 1 and 2 on here, then the minimum sum of this box is 1 plus 3 plus 4 is 8 is 24. No, that still works. There's definitely a 7 down here as well, FGem points out. Yeah, I can't quite break this being not an 8, because if this is 6, 7, 8, that does work in a way that is annoyingly not good. There's no 9 here, FGM points out, because if I did put a 9 in here, I would have 9 plus 6 plus 7 is 22, plus 2 more would be at least 25, and the maximum is 24. So the 9 in here is actually in one of these two cells. So that is something. Let's see. Ranks says it breaks if I do more, or if I look more. Yeah, the way I did it, it just worked, but who knows? Yep, I agree with that. Ranks about what would have to happen in order for this to work out. Can I break this being 22? Because if this sums to 22, then I would need to be up here. 7 and 9, plus 1, 2, 3, right? So I would need 2 of 1, 2, 3 in this column. And if the sum is 22 down here, the other digits would need to sum to 9. No, the other digits would need to sum to... No, 9 is right. The other 3 digits would need to sum to 9. And these digits would now only be able to include 1 of 1, 2. I think I'm redoing the same math that I was just doing again. Okay. So I know from before that if this is a 5... So if this is a 5, these have to be an 8-9 pair, for whatever that's worth. I know there's a 2 in one of these cells. Is that at all interesting, just by sudoku? Because one of those two is a 2. So one of these is a 2. Unfortunately, 2 here and 9 here works annoyingly well, I believe. I'm not quite sure which direction to be trying to examine here. Well, I guess I know that one of these digits is an 8. So I know that one of these digits is an 8. Is that at all interesting? Annoyingly, I don't think so. That's a good point to Selena. So Selena's point is these purple cells in this box sum to the same thing as these orange cells in this box. And so, therefore, because of that, these 4 cells have the same sum as these 2 cells. So is that interesting? So the minimum sum of these two cells is, if this is 1, 2, 3, 5, would be 11. It seems interesting that these 4 cells have the same sum as these 2 cells, but I don't yet see what it does. Uh, the minimum sum down here is 10, so I can't even rule a... Oh, I can rule a 1 off of this. That's interesting. Okay, so the minimum sum of this line is 10, which means the minimum of this sum is 10, which means it can't have a 1 because the 9 in the box is over there. So actually the 1 in this box, and this is a minuscule deduction, the 1 in this box is in one of these 2 places. Oh, FGem thinks they have it. That would be exciting. Okay, so... So the minimum sum in here is 11. And so FJam's point is these cells always need to have an 8 or a 9 in them, because I can't use 6 or 7. And so if I used no 8s and 9s, I would be at most 9. But I also need an 8 or a 9 in these cells, because these cells sum to a minimum of 10. And again, if I use no 8 or 9, because the 6 and 7 are gone, I would need to use a 4 and a 5. Or I could get at most 4 plus 5 is 9. So both 8 and 9 need to be used in these cells. That's really nice, FGem. Well spotted. And so therefore there's no 8 down here. And so this is an 8, which is the thing that I thought was going to be easy to prove, but proved more stubborn than I might have at first hoped. So we get a digit down here. And I'm not actually sure it does anything. So these are a 1 or a 3 and a 6, 7 is what is down here. I agree, Jay Dyer. I thought it was very likely that this was not going to be 8, and we were going to end up in that sort of pathological universe that we were exploring. Let's see. So I need to make these sum to something in some range. Could this now not... Is it possible that this can't be a 2? Because if this was a 2, 3, 6, 7, 2, 3, 6, 7, add to 18... yeah, that doesn't work, right? No, this could just be a 5, couldn't it? 2, 3, 6, 7 adds to 18 plus... Oh, this could even be a 4. Yeah, this could just have to be a 4 or a 5. Right. Okay, so Codec is pointing out this digit's never an 8 or a 9 because it sees the 9 there and the 8 there. So this digit's always an 8 or a 9. And so one of these two is an 8 or a 9. Uh-oh. I have become overly yellow. Zach must do his additional job as the de-yellowing penguin. We will see me turn less yellow, hopefully. Zach would very much like an intern to do that job. Okay, so this is an 8 or a 9, and the sum here is at most 8 plus 2 plus 3, which is 13. So this is at most a 5. Is that what I've concluded? 5 requires 2 8s in row 8. Okay, so this is only from 1, 2, 3, 4, because if this was a 5, this would have to be an 8, with this being 8, 2, 3. So yeah, so this actually can only be from 1, 2, 3, 4. Again, always sort of looking for... Oh, actually, this digit has to be from 1, 2, 3, 4. Oh, no, sorry, the betting tree exists. I forgot about the betting tree existing. Hey, SBQ. I was like, there's a hidden quadruple in the row, but no, this can be 1, 2, 3, 4. Let's see. So we said that in order for this to sum to 13, I would need... So in order for this to sum to 13, this would have to be 8 and 3. And so this would have to be 9 and 4. And because these summing to 13 means that these now sum to a maximum of 22, these would have to be now like 5, 8, 9 or something. Oh boy, this hurts my head. So Rankst is pointing out that these collections of 4 cells have the same sum, which is true. Codex says that breaks row 4, column 7. So the universe where this is 13, and so this is only 22. Oh, let's see. Am I already just screwing up math and I can do this much more easily? So this is at least 22. I don't think I know that red is at least 11. I think I know... Oh, sorry. I'm not following what FGM is saying. This is at least 22. Oh, the maximum for red is 12, right? The maximum for red is 12. So actually, yeah, the maximum for red is 12. Because I don't have enough 5, 6, 7, 8, 9s to make it higher than 12. I could do an 8 and a 4. Is the only thing I could do in some order. So red is at most 12. So that does say this can't be 3 and this be 8 at the same time. But this could still be 3 with a 7 if the sum is 12. And so if the sum was 12 here... So if this is a 3, this is a 7. Making the sum 12, which would make this an 8-4 combination, which would have to go 4 there and 8 there. Ah, right. Okay, so this can't be a 4, is Kodak's point. Because the only way this could be a 4 is if this sum is 12, but then this sum would have to be 12. It would have to be 4, 8. But if this is a 4, this cell can be neither 4 nor 8. So this is never a 4, is Kodak's beautiful point. So that's never a 4. Which you'd think would get us somewhere, but I'm not 100% confident that it has gotten us somewhere. So I have 2 1, 2, 3s in the box. Row 8 column 7 is already marked as only being able to be 8 or 9 changeable. This is a minimum of 22, I believe is what we proved. J40. I think. No promises, but I think that's what we proved. This is a minimum of 22. How can row 5, column 9 not be an 8? Oh, well, there's a question that might be interesting. Oh, it just can't not. Oh, well, one of these two is an 8, is what I actually know, right? One of these two is an 8. Is it a problem if this is the one that's 8, Mario? If this is an 8, then this is at most 7 and 4. Oh, no, this isn't at most 7 anymore. Sorry, there's a 7 there. Okay. So, so if that's the 8, then it would have to be like a 7-4 there, or 6-4 or something. That still seems plausible to me, unfortunately. Is there any way I'm sort of overlooking the power of this 4-5? Like, I could color 4-5s, maybe. Let's try coloring 4-5s, because I lack better things to do. So those are the same. That's the other one. That's that one. That's the other one. Is there any chance that this, like, bounces somewhere interesting? I don't think it does, unfortunately. So one of these is the circly 4-5. But it feels to me like that's got to be the more intended thing. Has got to be to, like, find some sort of coloring argument about Sudoku. Sudoku stuff with colors. I don't think I know which of these is the high digit. Okay, so Selena points out I can't have both 4 and 5 on this line. So this is not a 4-5 pair, because 4, 5, 6, 7... Wait, what's wrong with 4, 5, 6, 7? Because this can sum to up to 24. So couldn't it sum to 23? Because I don't know it sums to 22. Somehow both the world where it sums to 22 and the world where it sums to 24 are both restrictive, but I don't know which, and I don't think I've even really considered the world where it sums to 23 much at all. I guess in the world where it sums to 23, we actually know exactly Oh, maybe that's not true. The only reason, Mario, why I'm hesitant to use it is because your argument that this can't be a 6 was way more chain than I want to go down if I can avoid it. It's not that I don't believe you. I 100% believe that you're right. It just seemed it seemed like I was gonna have to do that, and then I was also gonna have to argue that it couldn't be a low digit, because this could be low, and then this could be, say, a 7 or something like that, and it worried me I was gonna have to make a really complicated argument. Is it interesting that the only way row 5, column 9, and row 6, column 8 can contain a 5 or 6 is if the sum of the big line is 24. Yeah, because if this contains a 5 or a 6, then yeah, automatically the sum of the big line is 24. In fact, actually, in that instance, it would have to contain a 6. And that would be the 5. Because remember, the minimum sum of this line is a 10, which I could not do if I used a 5 on this line. So is it just true I can never use a 5 on this line? I think it is true I can never use a 5 on this line, as useless a deduction as I think that probably is. But maybe I should just mark all the candidates for this, and then we should just slowly remove things from it. So I think I just argued this could never have a 5 on it. Oh, okay. So FGM is pointing out something which is very interesting, which is that if I want to make these digits sum to 24, it's quite restricted. Because I'm using 6 and 7 for sure, so that's 13. So if I want to make this line sum to 24, I would need 3 digits that sum to 11. But now those 3 digits cannot contain 6, 7, 8, or 9, so they would have to be 5, 4, 2. But they can't be 5, 4, 2 because they need to contain a 1 or a 3 by the row. Because remember, one of these has to be a 2. And so that does not work. Okay, so the sum is definitely not 24. Okay, so do I get anything out of the fact that these are not 7, 8, 9? Yes, because those aren't a 7, 8, 9 triple, this line has a 7, 8, or 9 on it. And so in particular, it does not have a 6 on it. So this digit could only be 2, 3, 4, or 8. And if I do the same thing for this cell can't be a 9, 8, or 5. It can't be a 6 either, because remember, I only get 1, 5, 6, 7, 8, 9, and it has to be a 7, 8, or a 9 to go on this line. And so that gets me some pruning off of this. So oh, good luck shoveling, Ambrose. We have just been getting drenched in snow, so I assume you are close enough by that you have also been getting drenched in snow. Okay, let's see. J40 says this cell is always a 1. Well, I'm trying to understand this. So row 8, column 7 is always 1 more than row 8, column 4. So if this is an 8, then that's definitely a 9. If this is a 7, then why can't this be a 9 and a 7? Let's try and understand that. If this were a 7 and that was a 9, 8 in row 8 is one of them. Oh, do I know for sure the 8 isn't over here? Right. I know this 8 is over here. Right. Okay. So, wait. I just flat out know the 8 in this. No, maybe I don't know that that's not the 8. But I definitely can't put the 8 in either of these cells. So I agree one of these two has to be an 8. And so, okay, so I do agree after careful consideration, the only two cells that can be an 8 in this row are these two. And so if this is a 7, that's an 8. If this is an 8, that's a 9. So this cell is always one more than this cell. Okay, I agree. And so if this is one more than that, then this being a 5 sounds bad, because then if these two sum to 5, that is if they're 2 and 3, this would have to be a 4. And we've said somehow it can't be a 4. So I think by the, like, it has to be one, because this is one more, this has to be one less than the sum of these, so this can't be a 3, so that's a 1 and a 3. I agree with that. And so now this can't be a 3 either. So now this just is a 2, because remember, it's one less than the sum of these two, because this is one more than that. So this just is always the 2. And so that's not a 2. Okay, good. Jay agrees with me about it being a 2. That is a positive. Oops. So, so we've got that being the 2. Okay. I don't think I said earlier that the red line couldn't be 10. I think, unfortunately, what I said earlier was that the red line had to be at least 10. But I could be wrong. This can't be a 2, because if it was a 2, then this would need to be the same digit as that, and it can't be. The red line definitely doesn't sum to 12. The red line either sums to 10 or 11. So this can't be a 4 anymore, because if this were a 4, the only way that, well, just no way works. This no longer sums to 10 or 11 with anything. Okay, interesting. Medi points out that digit's now just a 2, because I can only place 2 in column 9, not in any of these cells and not in any of these cells, and not in the row with a 2, so that's always the 2. Okay. So if this is an 8, that's a 3. Uh, 3 and 8 on the red line in box 6. So FGM is saying 3 and 8 breaks. So if I make this a 3 and 8, it places a 6 and a 2. Places 6 and 2. where does it place a 6 and a 2? On the other region's sum line. Right, because these two add to 8. Right. These two add to 8, I'd forgotten. So as soon as I use a 3 in either of these, then these are 2 and 6. And that's broken for some reason. I don't see why yet. I'm realizing, though, these two sum to the sum of these 4, and I don't think I really, when I was considering that, used that I knew these two sum to 8. So really, these two sum to 8 plus these two. Is what's really happening. So these two cells sum to 8 plus these two. I don't think these can possibly sum to 5, right? Can these two cells possibly sum to 13? I guess if they were a 9 and a 4? Maybe that would be okay. So technically this can't be a 4, is what I've just argued. If this is a 4, then I know that these cells sum to 13. The only way I'm making these sum to 13, oh, could it be a 5 and an 8? Oh, maybe it could be a 5 and an 8. It could be a 5 and an 8. That's unfortunate. That is very unfortunate. Okay. Rankska's saying that I can't put a 1 in either of these cells because these two cells do definitely need to sum to more than they need to sum to more than 10 because this is 8 plus 3 at a minimum. They need to sum to a minimum of 11, so they can't have a 1 in them. And so there's definitely a 1 around here. And the 1 is not there. So the minimum sum here is so the sum here is 1 plus 6 plus 7 is 14 plus 2 more things. If I used both 1 and 3, is that a problem? If I use both 1 and 3, then it's 17 plus 1 more number. I don't know if 17 plus 1 more number is that restrictive. Oh, it would have to be 17 plus 5, because 5 is the only option. So it would, of necessity, include a 5. I don't know if that's interesting. Yeah, 1, 3, 5, 6, 7 seems like a possibility to me. I know one of these is a 2, but I don't think that does anything. So let's see. Let's go back to FJam's point about something about the if this is 2, 6, something breaks. So if this is 2, 6, what is it that breaks? So if this is 2, 6, then this is 3 something. Oh, maybe it was specifically in the case that this was 2, 6 and this was 3, 8. Maybe that was the only case that broke. Because if this is 2, 6 and this is 3, 8, then I need these to sum to what? Do I know in that case? I've forgotten what I know in that case about what these cells sum to. It's got to be at least 22. So it would have to be 9, 7, 6 in that case. Right. Blue is at least 22. So if I don't use the 8 in blue, okay, I think I can finally string all of this together. If I don't use the 8 in blue, because blue sums to at least 22, this has to be 976, because that is 22. And if this is 976, then the problem is that this would have to be 8 and 3, but this would have to be 5 and 3, and that doesn't work. So pure agony, but this digit's not 8. And so therefore this digit's a 7. Is the point that we got courtesy of FJam. I can't imagine that's the intended deduction in any universe, but it is a deduction, technically. And so now we know where the 8 goes in the box, because the 8 in the box now only has one place. It can only go there. And so one of these is a 9. 5 here would be too little, because if I put a 5 here, this would have to be 5, 8, 9. No, that is 22, dang it. This 2-9 pair in column 1 does make that a 7. Agree with that. Box 1, I'm told, is going to have an 8. I don't see the 8 yet, but I presume it will be there. 9 in row 4. Right. No, I don't see it. 8 in box 4. 8 in box 4 only goes here. Thank you, Kodak. So that's not an 8, and so therefore that is an 8, because it's the only place for 8 in box 1. So that does something. 9 in row 4 is only in one place. So that's a 9 and a 6. Makes that not a 6. Good spot to Sarah. Let's see. So, question mark? Let's see. I know one of those is a 6. Medi says I can't put a 1 or a 3 on this line. I'm trying to figure out why. Is it that if I put a 1 or a 3, then the sum is too little? Let's try that. So if I try and put a 1, I'd have a 1, a 2, a 7, and a 9. Oh, it should have a 1. I am being told. The outies in box 3 must sum to 23 to 21, somewhere in that vicinity. So is the point that 8 plus 6 is 14 plus 5 is... Okay, yeah, so the point is this. 8 plus 6, which I know is in the outies, is 14, plus 5 is 19. So if I put a 1 on here, I only get to a maximum of 20, which would mean this is at least too big. So the 1 is certainly over here. But if I include a 1, 2, and a 3... Oh, I just can't include a 1, 2, and a... Oh, I could include a 1, 2, and a 3 if I put one of them down there. I don't know. I don't think I see why I can't put a 3 on this line as well. That's right. I do know that the blue line doesn't add to 24. It only adds to 22 or 23. Yeah, 1 plus 2 plus 3 plus 7 plus 9 is 22. And 22 is still an acceptable sum for this line, as far as I know. We proved the sum of the line isn't 24. We didn't prove it's not 22. So, let's see. What else do we have going on? I feel like this has got to be doing some work, but I certainly don't see it as of yet. Okay, Carl says I can't put a 5 on here. So Carl's claim is if I take 1 plus 2 plus 7 plus 9, 1 plus 2 plus 7 plus 9 is 19, plus 5, that would be 24. So I can't put a 5 on there. And so therefore the 5 always lands down in one of these two cells, is Carl's point. And so the 5 is over here. Is it possible that... Oh, maybe 5 can't go over here because we'd know what the sum would be. If a 5 went in one of these two cells, maybe that's the point. If a 5 went in one of these two cells, that would be 4, 5, 6 is 15, plus 8 is 23. No, that's fine. That would make the sum 22. That's perfect. So everything is okay so far. Okay, now that the 5 is down here, I know 4 of the digits, so I have to know the last one down here, because I know that this line contains a 1, a 5, a 6, and a 7. So therefore I know what the last digit is. So we're about to know what the sum is. Oh no, that's right, I don't know what the sum is. Never mind. Okay, so, but we can actually say... Oh, I also don't know that there's a 1 on here. I don't know anything. I know it has a 5, a 6, and a 7. So 5, 6, and 7 are 13. No, sorry. 5, 6, and 7 are 18. And so I need to either have I need to either add to 22, in which case I would need a 1 and a 3, or add to 22 would need a 1 and a 3. 23 would need a 1 and a 4. Is all I know. It does have a 1 on it. We do know that. And if we didn't know it, we just proved it anyway. Let's see. So... let's see. Carl says in box 9, 1 plus 5 plus 6 plus 7 is 19. And in box 3, 1 plus 2 plus 7 plus 9 is 19. And so if the sum is 23, then both of them have a 4, because I can't put... Okay. So the point is that Carl is making is that these currently, if you take the 4 digits we know about on each of them, the 4 digits we know about on each of them sum to 19. So that is 1 plus 2 plus 7 plus 9 is 19. And 1 plus 5 plus 6 plus 7 is 19. So whatever the last digit is, it's the same in both. And the point is that digit can't be a 4, because if that digit was a 4, remember the 4-5 pairs rule 4 out of these. So therefore the sum can't be 23. The sum must be 22, which means that the digit that is missing on these is a 3 in both cases. Because I would put 2 4s in column 9 ranks, because I can put 4s neither here nor here. And so I would need to put a 4 on both of these lines, and both of them would go in column 9. Which is a crazy deduction, but there we are. Okay, so let me write in what these actually are. So these are 1, 3, 7, and 9, I believe. Because 1 plus 3 plus 7 plus 9 is 22. And these are 1, 3, 6, 7. That's not enough digits. What else do I need? Oh, and 5. Right. I knew there was a 5 in there. Right. Okay. So, no 7 there. No 3 and 6. No 3 in the corner. Let's get rid of all of these horrendous corner marks. 3, 6, and 7. And I know the 6 and the 7 are down there. So that's not a 7, and that's not a 6 or a 7, and it's not a 1 either. Okay. So, I know the sum of these 2 digits now needs to be, well, sorry, the sum of these 3 digits has to be 22. And so 22 minus 8 is 14. So that, therefore, this needs to be 5 and 9. So that's the 5 and that's the 9. So that is probably going to finally do it on our fully pencil marked grid now. 6 and 6, and 9 and 6, and 4 and 7, and 4 and 6, and 2 and 9. And I'd ask pencil mark to help, but we've already penciled the entire grid. So we can't. So therefore, this is now a 5 for some reason. There we go. It's a 5 and a 5, and a 4. And a 5 and a 4, and a 6, and a 3 here, and a 5 and a 1, and a 7 and a 6, and a 5 there. That's not a 6, so it's a naked something. So 1, 2, 3. So this is a 4. So that's a 3 and a 2 and a 4 and a 3 and a 7 and a 9 and a 1 and a 1 and a 3 and a 2 and a 3 and a 1 and a 5. And a 4 and a 3 and a 2 and a 1 and a 7 and a 5 and an 8 and a 7 and a 1 and a 4 and a 3. And that is a 9. And 1, 2, 3, let's see, this is a 4. And the betting tree is an 8. Whew! What a puzzle. But congratulations to all of the 8 bettors out there. May all your betting tree wishes come true. I don't think we found the right end of this puzzle. I think like the beginning of the puzzle was all so smooth and natural, and every step sort of made sense. And then at the end of the puzzle, we spent 60 minutes removing a candidate at a time until we got the like ugliest final deduction I've seen in a puzzle in quite some time. So I suspect that the end was meant to be done some other way. But I will say, again, if you're a newer solver, I promise that most of Kuraban's single constraint puzzles are not like this. They're mostly gentle and lower star puzzles. I promise. So go and do those. Maybe don't do this one if you're a newer solver. But I promise they are awesome on average. But very Oh, Kuraban says we did not pay sufficient attention to the fact that we knew from the beginning that one of these was a 1-2 pair and one of them was a 2-3 pair. Which is which is very true. I definitely never thought about that again after the very beginning. That might have made it a little bit easier at the end. But yeah, at least the way we did it, the ending was very, very, very grindy. But the beginning was very cool. I liked the setup. I mean, people have used this setup a lot, but it's a very cool setup. It's just a very neat region sum lines deduction to do this sort of trick with the 15s that have to be different. Alrighty. I'm going to take a quick break. I think I've earned it after that. And then come back with more puzzles. If you've not yet liked the stream, after that puzzle, I think I've earned it. So please take a second to click the thumb button to like the stream. As Andrew said earlier, please click the thumbs up button and not the thumbs down button. That will help us out. Greatly appreciated. And I'll be back shortly. I don't know if I'm going to be back with a 6x6 or with a none 6x6. We shall see. But I will be back in just a moment. Alrighty, let's do a killer puzzle by Tyrgannus to finish up the stream. So completely normal rules, completely normal killer rules. We need to keep the sums the same to the indicated number, and we can't repeat digits inside this. Let's see. So we know things like that 15 cages always have a 6, 7, 8, 9. We know that every 8 cage needs to have a 1. And we're certainly going to get to play the game where when we look at these 2 cells, we're going to get to ask where these 2 cells go in this box. And find out that they can only go in a handful of places. Oh, that's right. We need a betting tree. How about we put a betting tree right there? That looks like a good betting tree. Let's see. Do I know? Is there anything interesting to be said about a 32 cage and however many digits that is? No. Quick answer, no. These 3 cells sum to 15 minus 6 is 9. So these 3 cells summing to 9 is interesting. That means they're at most 6 for whatever that's worth. SPQ makes a donation and says, will you get rid of the spurious 1 next to the button? Can you tell me what spurious 1 next to what button? And I probably will if I know about the 1 next to the button. Well, thank you for the donation. I will have Zach do a dance while you articulate what spurious one we're talking about. Woohoo! Thank you, Zach. Thank you. Spurious one dance. I'm still not sure what the spurious one is referring to. So I'm going to highlight that these sum to 9 because it seems relevant. Now, Garion found something else that summed to 9. Let's see if I can figure out where that was. Let's see. The Audi's in column 5. Oh, right. Okay. So the 22 and the 14 add together to be 36. So these also sum to 9. So both the green 3 cells and the blue 3 cells add to 9. And so the only digits that can go in a 9 sum are 1, 2, 3, 4, 5, 6. However, 6 only goes in the 9 sum 1, 2, 6. 5 only goes in the 9 sum 1, 3, 5. 4 only goes in 2, 3, 4. Sadly, 3 and 2 and 1 all go in multiple 9 sums. But actually, that does tell us that these digits... Oh, I have a digit. These are all from 1, 2, 3, 4, 5, 6. Oops. Oh, I don't have a digit. I was going to ask where these cells go in box 5, and at first I thought they just had to go here immediately. But they don't. If this is 7, 8, they have to go there immediately, and this is a 3. But if this is a 6, 9, I could hide the 6 there, and then not make these two add to 15. Let's see. This 9. Well, I know this digit is definitely in that 9 cage for similar reasons. Because the 9 cage's digits can't end up there. So Garion is looking at the Audis through here. So the Audis here only add to 12. So these 3 add to 12. And so Garion's point is because they add to 12, these can't both be from 7, 8, 9, which means that both of these are from 7, 8, 9. For sure. So the last of the 1, 2, 3, 4, 5, 6s is in there. So one of these 18 cages has 2 7, 8, 9s in it. Unfortunately, that doesn't quite work. Oh, interesting. Does this 18 cage have to have a 1? Okay, this 18 cage has to have a 1 and a 2. Medi points out. I had not noticed that. The 1 can't go here, so the 1 needs to go in one of these 2 cells. And that's creating some interesting geometry with these 2 8 cages, which is going to guarantee that this cell's never a 1. And so the 19 cage needs a 1, but that 1 can only be in one of these cells, because it can't be there, because if it was there, it would rule a 1 out of this whole cage entirely. Let's see how this works. A 1 here, puts a 1 here, puts a 1 there, puts a 1 there. That's okay. So that is all well and good. That part's not as exciting, at least not immediately. But hey, we've got a 1 over here. Oh yeah, Afraid Not is right. I can't make this a 1. Because if I make this a 1, then I force that to be a 1 and one of these two to be a 1, and now I can't put a 1 in here. Or alternatively, if you want the fancy argument, since we did this earlier, I'll do it again. The fancy way of framing this is this. These 4 houses need to have 4 1s in them. And so that means I need to get a 1 from each house. And if I put a 1 in a corner or an intersection, then I've only put 1 1 in those 2 houses, and then I can't get to enough. So this is exactly the same argument that we used in the Jay Dyer puzzle earlier to place the 8 doublers. So good spot. So those are not 1. So now I think we actually know that one of these two is a 1, maybe, possibly. If neither of these is a 1, then that's a 1, and that's a 1, and that's a 1. So yes, we know one of these two is actually a 1. Do I know one of these two is actually a 1? Probably not, because of that cell down there. Let's see. Good night, Kodak. It's a good point. Garian's point is, I know that the third 7, 8, 9 is in one of these 2 cells. And I know that these 3 cells sum to 12. And so if I have, say, the minimums of a 7 and a 1, the maximum the other cell can be is a 4. So in other words, there's no 5 or 6 in here. And so my 9 sums, one of them has a 5 and one of them has a 6. And that tells me what my 9 sums are. Namely, my 9 sums are 1, 2, 6 and 1, 3, 5. And so 1, 2, 6 and 1, 3, 5, the only digit they share in common is 1, which gets us a 1 in the center of the grid. And so we get to do the 1 dance. Ba-boop-ba-doo, woo! Ba-da-ba-doo-boo, woo! Ba-da-ba-da-ba-da-ba-da-ba-boo! Ba-da-ba-ba-da-ba-boo! Ba-da-ba-ba-da-ba-boo! Thank you, Zach. Thank you very much. The non-spurious one this time. And so we can actually write in that none of these digits are 4. 4 is the missing digit over here. Because we said that they are 1, 2, 6, and 1, 3, 5. None of them are 4. So therefore, these digits include a 4, and they sum to 12. So 1 plus 4 plus 7 is what happens. So these are a 4, 7 pair. These are not 7 anymore. Those are an 8, 9 pair. And so we get to look at this carefully. And so if I have an 8 or a 9 and a 4 or a 7 in an 18 cage, what is the other digit? So 7 and 8 would be okay, right? 7 and 8, yeah, well, that would make that a 3. 4 and 8, that 5. Okay, maybe every possible option works. That's very plausible to me, that every possible option works. I know there's not a 1 in here, at least. Is there some option here that would break every possible way of making 14? That's a good point. So Screaming Ice Cube says, I can go back to my earlier point about these two needing to go in this box. Now I know this one at least is the purple one. Let's see. Okay, so I should, of course, look at these cages. So the 15 cage doesn't have a 1, and it doesn't have a 4, and it doesn't have a 7. And so the point is, and Todd is the one who told me this is a 2, 5, 8. And so this is the other thing. 2, 3, 4, 5, 6, 7, 8, 9. This is a 3, 6, 9 cage. for sure. So it's interesting that this can never be 7-9, I'm noticing. Because if this was 7-9, it would break that cage. So because this can't be 7-9, they can't sum to 16, so this can't be a 2. It's the most meager of deductions ever, but it's true. I know this isn't a 2 now. Okay, so Garion says if this is a 7-8 cage, that's gorgeous. If this is a 7-8 cage, then it needs to go here, and then it goes in here, but then we have a massive problem because I have 7-8 plus what equals 22, and the answer is 7. And so you would have to have 2 7s in here. And so actually, this can't be a 7-8 cage. It can only be a 6-9 cage. And this has to be a 6, because it's the only place it can go. So that's the 6, and that's the 9. So that's the 8. Very nice. No 6, no 6s up there. Okay, so these 2 cells need to add to 9. These 3 cells need to add to 9. Let's start with that one. So that's a 2. Okay. Now this is maybe an easier problem. So these 2 need to add to 9. They can't be 3 and 6, so they have to be 5 and 4. And so that's a 3 and a 7. And so we get the whole box done. So that cell already couldn't be 6. AFK. This cell had to be 7, 8, or 9. Oh, did I screw this up? Right, I don't think I know that. Right, okay. So that is the 8 and that's the 9. But I was thinking I knew the 6 couldn't go in here, but I don't. Right. Okay, so we at least get there, though. So these 2 need to add to 10, so this is never a 5. So it's either 4, 6, or 3, 7. These 2 need to add to 9, so it's either 4, 5, or 7, 2. So this is never a 3 or a 6. I guess that's kind of makes sense. So this is either 2 and 7 or 4 and 5. So yeah, so the thing is, it's not a problem if the 6 goes over here and we end up with a 7 in this cage. Let's look at this 14 cage. It doesn't have a 6 in it. It doesn't have a 9 in it. So that tells me basically nothing. Why can't it have any 5s? Oh, it can't be 2, 5, 7, because that would break this cell. I agree with that. So it's either 2, 4, 8, or 3, 4, 7. So it always has a 4 in it. It's a weird deduction. So the 22 cage doesn't have a 4 in it. Whatever. It definitely has a 9 in it. Who knew? Selena says I can't put an 8 in any of these cells. Is it obvious that this can't be a 1, 8, 9 cage? Oh, right, I didn't notice it before, but actually I know one of these 2 is a 1. Somehow I noticed one of these 2 had to be a 1, and noticed I didn't know one of these 2 had to be a 1, but I could have noticed by exactly the same argument one of these 2 is a 1. And so I can't put an 8 in here. If I put an 8 here, all of these cells would have to be from 1, 2, 3, 4, 5, and that's too many cells from 1, 2, 3, 4, 5. So that's not an 8 either. And so Selena's point is there's definitely an 8 in here, and so this has to be a 5, 8, 9, which immediately makes that a 2 and a 7, and a 4 and a 5, right? No, that's not right. 4 and a what? 4, 8 is 12, and 6. There we go. So these are not 2 or 6. That is a very nice spot. So therefore, this does not have one of these things in it. It doesn't have an 8 in it. So this is 3, 4, 7. The laziest of uses of the killer cage calculator to avoid having to write in a triple. So this 9 cage is now forced because it's not 1, 8. It's not 2, 7 by the column. And it's not 4, 5 by the box. So it's 3, 6, making that a 5 and a 3. So now, where is the 3 in the 18 cage? Oh, the 18 cage doesn't have to have a 3. Never mind. I thought 18 cages had to have a 3, but that's not true. So these remaining digits, how about I just fill in those, are a 1 and a 2, 3, 4, 5, 6, 7, 8, 9. Not a 6. We already have a 6. None of those are 4, though, so that's the 4. These are a 1, 2, 7, which means that's not a 1. It's the other thing. 3, 4, it's a 5 just by the column. And now this is the 1. Oh, no, this is the case where I don't know where the 1, or I don't know that there's a 1. Oh, but up here I knew that one of these two was a 1, so that one's definitely the 1. And so once that's not a 1, we get that. So now one of these two is the 1 for this column, so that's not a 1. One of these two is the 1 for the column, so that's not a 1. So now this is the 1 for the row. And so now this is the 1 for the column. So we get all of that. There is no 5 in this 8 cage, so this is a 3, 4. There is... I was hoping I could say something clever about this 8 cage, but I don't think I can. Let's see. So we've got a 1 and a 4. Oh, right. This 2 has gotten shunted over here, so this has become 1, 3, 4, is Garian's point, because I can't have a 2. So that is a 1, 3, 4. And so if this doesn't have a 3 in it, this is now a 1, 2, 5, 6, like that. And so we can fill in these digits. 1, 2, 3, 4, 5, 6. These are a 7, 8, 9 triple. I have a Jovio on 3s, which means that one of these cells is a 3. Going through there. Let's see, this 19 cage has a 5 in it. Is that at all interesting? Not that I am able to ascertain at this particular moment. This is a pair. Let's fill in that. This is a 2 and a something. 3, 4, 5, 6, 7, 8. It's 2 and an 8. I don't think I know anything about 2s and 8s in such a cage. Let's see. Oh, well, I now know where this digit goes in this box. It has to go there. So this digit, I'm going to make it a different color than that one, just to distinguish it. Because this digit now can't go there. So this yellow 2-8 is that yellow 2-8. I don't need any of this colored anymore, I don't think. We're going to start sort of single digit coloring. How did I... Did I screw up something in this box? There we go. Okay. There we go. We got it back somehow. I don't know what I did. Okay. If this digit is a 3 or a 4, then it has to go there. Otherwise, this digit's not a 3 or a 4. In which case it can go anywhere it likes. Okay. So this could go 3, 4 like that. If this is a 2, it could go there. If it's a 7, it certainly can't go there. I agree with Afraid Not that I can pencil in these, and so this isn't the 2 or the 3, so this isn't the 4 or the 5, just in terms of there's only 2 ways to make an 8 cage. Let's see. FJM says I need a 1 in this cage, which I can verify by the killer calculator is true. And so just by sudoku, it's in one of these. No, it's not in one of those 2 cells because of that 1 looking at it, and it's not there or there. So the 1 has to go there. And this 32 cage down here, it also needs a 1. But now it's got a 1 looking at it across there, down there. And so it's got to have a 1 there. And that 1 there places a 1 there. And now the remaining 3 cells in this box have lots of options. But the remaining 3 cells in this box sum to 13. Plus 17 is 30, means these 3 sum to 15. That's not very interesting. Oops, I was not trying to do that. Oh, there's only one more 1 in the grid. There's only one more 1 in the grid. And the 1 in the grid goes there. Well, that's very helpful, because now these are a 7 and a 9. And now I have a Jovio on 9s that tells me that there's a 9 over here. And then there's one more 1. The one more 1 goes here. I seem to now actually have all of the 1s. Let's see. And there's no 7 in this cage. So there is a 6 or an 8 to go along with it. I can't quite string together coloring these 3 4s yet, I don't think. My 32 cage is one of the flavors that has a 9, for whatever tiny amount that is worth. Let's see. Let's see. FJam says I should look at the fact that there's got to be a 3 and a 4 in this cage, and those can't be 3 or 4. So one of these is 3 or 4. Yeah, so by killer calculator magic, I need a 3-4 in this 32 cage, and the 3-4s can't go there. So I can't put both of them here. So one of the 3-4s goes here, but more interestingly, one of these 2 is a 3 or a 4, which gives me a virtual 3-4 pair, which makes this a 7. At least we have the killer calculator now to do this kind of horrendous nonsense. Let's see. So I now definitely need to start coloring the 3-4s. Because this is sort of the perfect setup for coloring 3-4s to be relevant. Let's see. So yeah, those 2 now are the same. We're is 9 in column 3. It's there. Thank you, Screaming Ice Cube, and thank you to AFK for summarizing for me. So that is a 9. Oh, let's see. Okay, so J40 is saying that this has to go in the 31 cage just by looking at all the cases. I don't see why I know that it doesn't go there. Oh, I do see why I know it doesn't go there. Wow, that's crazy. So this has to go in the 31 cage, and the only places it could go in there are there and there. Except if you look closely, it can't go here because there's a 2 and a 3 in the row. So this 2-3 is that 2-7, which means they're 2s. That is a really good spot to J there. So that's a 5-6. That's a 2. It's an 8. That's very slick. Not a 2, not an 8. This row needs the rest of its friends. 4, 5, 6, 7, 8, 9. This is an 8. It's not a 7. Maybe did not do as much as I'd hoped about. So now this digit and that digit are definitely the same. So this digit is a 4, 6, 7, 8, and I think it could be literally any of those. 7 in column 7, I'm being asked about. Do I know there's not a 7 in here? I do somehow know there's not a 7 in here. Ah, right, because there's a 7-9 pair down there. Okay, so the 7 in this column is there. Okay, very nice. To, again, the team of Screaming Ice Cube and Afraid Not. So let's see. So, yeah, I still don't know what's going on here. I know that there's a 3 and a 4. Well, I know there's a 4 in this cage. Oh, no, I don't. Yeah, I know there's a 4 in the cage, but it could go either of those places. Right. Okay. So Mehdi is pointing out, I know that these are a 3, a 4, and a 9. Because I know there's a 9, and I know the other 3, 4 is in here. That's actually how I got all of these pencil marks. And so, therefore, this is a triple of the other stuff. 2, 3, 4, 5, 6, 7, 8. So we've got all of that. Now, we only get 1, 6, or 8 in our 19 cage, so therefore that's a 2. And so, because we only get 1, 6, or 8, well, actually, it's just an 8, and that's a 3, is what the killer calculator is telling me. This feels very much like a, and that's what the killer calculator told me, puzzle. So this isn't a 6 for lots of reasons, not least of which is that there's a 3, 6, 9 triple in the box, so that's not a 6 either. Let's see, I am told there is some cleanup that can be done, laying around the block. This isn't a 6 either because of the same triple. I know for sure that one of these two is an 8. And so because one of those two is an 8, this cell is never an 8. I'm moving over towards this box for cleanup that people are talking about, which is very, very believable. Okay, these are a triple. Let me write them in and see if that tells me anything. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get that. Oh, but none of these are 9 because there's that. So actually, this is a 7 and a 2 and a 9 and a 9 and a red X digit. Okay, so we've got our various 3 4s. That 7 has looked down and given us the 9 and the 7 over there. No 9, no 7. That has become a 4-8 pair. So that has become a 6 and a 7. Okay, so this cell sees a 4 and an 8. Is that interesting? No, not really. This 5-6 pair looks over and says that's not a 5. So this can only be an 8 or a 9. So these are a 3 and an 8 or a 9. But there's only one 8 or a 9 in the box. Or sorry, in the cage. So a 31 cage, you can learn from your killer calculator, only has one 8 or 9. And one of these cells is an 8 or a 9. So this can't be an 8. So that's a 4 and a 4 and an 8. Tyrgannus, I know, just knows absolutely all of these things just off the top of his head, which is always amazing to me. That is a 3 and a 4, and a 4 and a 4 and a 3 and a 3. It will surprise absolutely no one who spent any amount of time watching the stream that I cannot do killer math in my head. 6 and 3. 6 and 9. Let's see. Do I know what this is yet? I still don't know what this is. I know that this is a 5 or an 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, certainly I can do a lot of like min-maxing sort of killer calculators, or calculations in my head. Oh, Mark is back. Hey, Mark. But like nothing in this puzzle has to me seemed like an easy calculation. Like this has all been like very much like there's 5 options for this thing, and if you pencil mark this, it is so great. It is amazing. It is one of my favorite things. So there's a 5-9 pair, so this is a 6. So this isn't a 6. And so now these need to be a 3 and an 8, says the calculator. So they're a 3 and an 8 in that order, except I did the wrong thing. So they're a 3 and an 8 in that order. So that's a 6 and a 9 and a 3 and a 5. And a 5 and a 9 and an 8 and a 5 and a 9. And this cage now definitely has a 2, and every place that 2 could go sees this cell. In fact, every place that 2 could go is this place. So these are both 2s. So that is an 8 and a 5 and an 8 and a 6 and a 7, and a 2 and a 6 and a 5 and an 8 and a 5. And this is a 4, and our betting tree is a 5. Congratulations from Zach and I to all of the 5 bettors out there. May all of your betting tree wishes come true. I love the killer calculator. The killer calculator lets me like open killer puzzles without worrying that I am going to be slaughtered. I mean, the killer puzzle might be hard, but I mean, this would have just been literally impossible for me without the killer calculator. Like, chat would have been saying things like, every 14 cage in 3 without a 6 and an 8 has to have a 7, and then I would have been trying to like see if that was true or not, and it would have been terrifying and scary, and difficult to communicate. But with the killer calculator, it's easy. And lots of you in chat do know all of these things, and so you can say them, and then I can just verify them by clicking on the button, and then it's magic. So I think this is a fabulous addition to the wonderful world of Sudokology. Alrighty. Please take a second to like the stream if you've shown up during that. It is always appreciated when you do. I see we've gotten up to 57 likes. Zach will do a special dance when we get to 100 likes. I'm going to take a very quick break, and then we'll be back, and we're going to do some 6x6s to wrap up. So we will be back very shortly. wrong mode. Welcome back. Now in CTC. All right, so we have a Math Pesto 6x6. This seems to be a reference to the Math Pesto puzzle DDR, which I just loved, which had exactly this collection of constraints. But let's see. So what are the constraints? And let's make sure we understand what the constraints mean in the case of a 6x6. This is a quadruple. It means that one of these digits is a 1. We need to make sure that along a German whisper line, adjacent digits differ by at least 3. These purple lines are Renbahn, which means they need to have a string of consecutive digits in any order. And on my entropic lines, I need to make sure I have 1, 1, 2, 1, 3, 4, and 1, 5, 6. And for all of these, that's just it. You just need to have one of each on there. So I guess one thing I notice is that a length 3... Oh, I was going to say that this needs to have a 3 and a 4 on it, but that's not even true. Well, I know that this isn't a 3 or a 4. Let's start with that. None of these cells can be 3 or 4 because each of 3 and 4 only are 3 away from one digit, and we need more than one digit for them to be 3 away from. So these are 1, 2, 5, or 6 as my only options. Now, I might be able to do better, but I don't think I can. Yes, I do not think that I can. I can do better on this. So if this was a 5, these would have to be a 1, 2, and that doesn't work because they would be the same thing. And similarly, if this was a 2, these would have to be a 5, 6, and that doesn't work. That is, Selena and AFK were noticing that. And so same thing here. These are not 2 or 5 either. And so this has to be joined by one number that's a 3 or a 4, and one number that's the other flavor of 5 and 6. And so whichever digit that goes with this has to go over there. So these two are like colored. I'm just going to make up the color green for them, maybe. That looks terrible. We're going to flip through an alternate color palette. We're going to pick sky blue for them. This has to be the 2, 5 that goes with this. Because remember, one of each pair needs to go on this entropic line. And that one isn't there, so therefore the other one has to be. And so this is a 2, 5 as well. Yeah, the new palette has a few issues. The white outline is one of them. But I wanted some colors that weren't going to overrun the colors that were floating around already. So I'm trying to decide. Right. Okay. So that's the point. Okay. So right. Okay. Sorry, my brain is confused. This digit, whatever it is, it has to go on here somewhere. So anytime I can highlight the 3 digits of an entropic line, the 3 digits not on an entropic line, and they have to be one of each high mid-lowity, which is interesting in and of itself, I believe. Uh, so, yeah, so my whisper here, or sorry, my Renbon here, I think this is what FGM is getting at. My Renbon, my Renbon could be 1, 2, 3. But, even so, I need to make sure that one of the digits is middle, because no length 3 Renbon can span low, middle, high. There's not enough digits. And so I need to either use a low in a middle or a high in a middle in these. And so therefore these digits are never middle. That is FJam's point. So these are from 1, 2, 1, 2, 5, 6. Because one of these was already middle, is the point. And wherever this one is, needs to go, its partner is not on the Renbon. Its partner needs to go in one of those two places. FGM says that was not quite their point. I see now. Okay. So the point is this digit isn't middle. Which in my brain, 5 was a middle digit because I was stuck on my 9x9 entropic lines. So one of these is a 3. So FGM's point is one of these is a 3 or a 4, and one of these is a 3 or a 4. So therefore, neither of these can be 3 or 4. So these are from 1, 2, 5, 6 as well. So these are either a 1, 2 pair or a 5, 6 pair. And therefore, this is a middle. This has to be 3 or 4. Because I can't connect otherwise. And so we can do the same thing over here, where one of each of these has to be a 3, 4. And so this has to be from 1, 2, 5, 6. And this has to be from 3, 4. Let's see. Okay, so yeah, one of these is a 3, 4. I don't think I know that there aren't more than 1, 3, or there isn't more than 1, 3, 4 along there. I would love to know something like which of these is the 3, 4, but I don't think I know that yet. Oh, Garion did this puzzle in a different way, which is very interesting. I do feel that's very likely, Ransk. Let's see. So I only get one more 1, 2, 5, 6. And these two are the same. Maybe I should color these instead of these. Let's try that. Maybe that's more useful. Because these are the same sort of thingy thing. And so this is the other sort of thingy thing. And then this is yet another sort of thingy thing. That purple looks too much like that. Let's use the burnt umber instead. So this has to be blue because I need a blue on this one. And remember, the one opposite that is the same. So that gets our coloring a little bit further already. Which is helpful, I suppose. Ah, and now where does blue 1, 6 go in column 1? Blue 1, 6 in column 1 can't go there, because then I would need a blue 2, 5 in one of these two cells, and I can't have it. So that is blue 1, 6. Okay, we have our first deduction of the puzzle. So that's a 1, 6 pair. So this cell is not 1 or 6, and this 1 or 6 is yellow. So that 2, 5 is yellow. And now this cell sees both 2 5s. So it is 1 or 6. I don't think I know which 1, 6 yet. Maybe if I squint carefully at what these digits can be. So at least one of these digits is blue, if not both. Do I know this isn't yellow, or that it is yellow? Oh, right. Right. This has to be turquoise because of the entropic line. This is FJam's point, but I didn't see it at first. But neither of these can be this sort of nice C-ish color. So therefore, because I need one of them to be the C color, that one has to be the C color. I don't have any choices about that. And so, therefore, where do these go in box 6? In box 6, the C-color ones have to go there. So these are from 1, 2, 5, 6. And now these two have to be the same color, and it's not blue, so it's yellow. This is still burnt umber. And let's see. So now that's yellow, because I need a yellow on this line, and it's not there, so that's yellow. The other blue is on this line in the column, so therefore this is burnt umber. Oh, and in fact, that's burnt umber too, if I listened to Rank's point, because I just had everything else in the box, so I did that in a much more convoluted way than was necessary. Is Rank's point. I already have both the yellows, so therefore this is blue. This sees both blues and both yellows, so it's burnt umber. And therefore this is the last yellow in the column. And it's, no, sorry, not the last yellow. This is the last blue in the column. I can count, I swear. This is the last blue in the column. So now this cell can't be blue, but I need a blue in one of these two cells, so it's that one, and this is the one that's umber. This cell can only be umber, because I can't have blue, umber, yellow as my combination. So that's yellow, and so that's blue. This cell is now yellow. And so these go umber, umber. That's yellow. So therefore that is umber. And therefore that is yellow. Oh, this is umber. So this is yellow. This is neither blue nor umber, so it is yellow. And this is now umber by literally whatever house you want to look at. So we have that. So now this I know is a 2 or a 5 because it goes on a Renbon with a 3-4 pair. And so that 2 or a 5 looks down and makes that a 1 or a 6, which makes that a 2 or a 5, which makes that a 1 or a 6, which makes that a 2 or a 5, which makes that a 1 or a 6. That's a 2 or a 5. And this is a 1 or a 6. And there we go. Now, as Ranks points out, now the 1 on the quad tells me that yellow is 1 because neither of these blues is able to be 1. So the yellows are both 1. That yellow's a 2. This is a 6 and a 5, and 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 a 5 and a 6. And this is apparently only able to be a 2, and a 1, and a 2, and a 1, and a 2, and a 1, and a 2, and a 2, and a 1. And so now this is a 4, and a 3, and a 4, and a 3, and a 4. This is a 3 and a 4 because of the magic of this. This is a 4 and a 3 because I needed the Ren bond to work, in other words. That is 3 and a 4, and that's a 3. Very nice. Oh, Garion did high-low coloring instead. Very interesting. It was a fun day of puzzles today. We had a lot of neat stuff going on. That was a fun little puzzle. Interesting. Yeah, it's always tricky when you have both entropic lines and whispers floating around to decide exactly how to go about coloring it. I usually default to the entropic coloring, but very interesting that different approaches work. Alrighty, well, thank you everyone for joining me on today's puzzle adventures. It's been a fun day. We did have our first 90-minute solve in a while. Possibly our first since we did Navario's monster battleship puzzle. I'm not 100% sure. But anyway, thank you all for joining me. I'll be streaming again on Sunday, so you can look forward to seeing me then. You can always subscribe if you're new. By the way, if you're new, welcome, and please feel free to introduce yourself in the chat. I always like to see the new folks chatting. I know it takes a bit to sort of get comfortable and get your feet wet, but whenever you're comfortable, say hi. I'm always happy to hear from new folks. Anyway, if you would like to support the stream, you can do so for as little as $5 a month by clicking down on the join button down below. And you can do that. I stream about 50 hours a month, I believe is what I decided. So if you would like to support that, you can do so. And then you get things like the green name and the Zach emotes. And you can vote on what puzzle we open stream with. And then I can figure out the Discord is broken and didn't show me the right votes. And then we can have a fun game about that. But anyway, I very much appreciate all of you who do support the stream in whatever of the many ways that you support it. Even if it is just noticing when I delete pencil marks that I'm not supposed to. Whatever it is, I appreciate you all. I love doing this. Thank you so much. I hope you all have a wonderful day. Thank you also to all of my turbines, David, Michael, Nordy, Franco, Woofer, and Andreas. Thank you very much, and I will see you all soon. Jim mentions the 3-hour plus puzzle. I think the 3-hour plus puzzle was Battleship by Navario is the most recent one. Before that was some Jesper aquarium puzzle that we butchered by solving without ever finding the break-in. Which we also did do a KNT puzzle recently. But I don't think the KNT one ended up taking that long. Maybe it did. There was a KNT sandwich puzzle that took a while recently, but I don't think it was up to 90 minutes. Maybe. Anyway, thanks for watching. I'll be back soon. Bye for now. Oh yeah, Naplu Ultra was definitely over 3 hours, but that was a long time ago. That was way, way, way before Battleship. I've done plenty of solves that were longer in the history. I wasn't saying it was the longest puzzle ever. I was just saying I think it's the first really long puzzle we've done since we did Battleship, which was an intentionally done longer puzzle. Because I think I knew going in it was going to take about 4 hours. And then I think it took about 3 hours, if I recall correctly. But I think did it beat Carousel? Did it not beat Carousel? I don't remember. Tristan is looking it up and is going to tell us the actual facts about puzzle lengths and solving. Oh, the Chaos Loop puzzle by Jacob and Woofer was 2 hours. Okay. So yes, so we have had a long one. I will say to the credit of that puzzle, it did not feel like almost 2 hours. Either that or I've blocked it out completely and I only remember a little bit of it. But I don't think I felt like it was that, so that's good. Anyway, I will see you all soon with, oh, Garion, yes, Garion, oh boy, yeah, Garion mentions the 6x6x6 puzzle by Tesseralis that was like vignettes, taken up a notch, because Tesseralis is the kind of person that looks at vignettes and thinks, you know what would be great? A version of this that was even more bonkers, and then is like not just a little bit more bonkers, was a lot more bonkers, but it was a very memorable puzzle. Andrew Sarkis threatening the sequel 6x6x6x6, which is a slightly terrifying thought, but it will probably happen if Sudoku goes on long enough. People keep making these terrifying looking three-dimensional puzzles. Boy, I think that three-dimensional Ring by Wisteria is one of the puzzles of recent ones that has most broken my brain trying to think about what was going on with the rings wrapping around the sides of the cube and everything. That one was very difficult on my brain. Not that it wasn't very cool, but that was very difficult for me to conceptualize and think about. And people in chat kept trying to describe how to visualize it, but then chat would very much disagree about what the thing to try and prove was. A 3D yin-yang. I feel like there must be an interesting combinatorics behind a 3D yin-yang, given how much weird combinatorial constraint there is in a 2D yin-yang. I feel like a 3D yin-yang would have to be particularly that. What if it was just two yin-yangs that had to lay on top of each other, and you just said you couldn't have a 2x2 vertically or in either of the two constituent yin-yangs? That might be enough to already make it entirely imparsable and unscannable. I like that. I kind of like that idea, but please don't make me do it. It's interesting, like 3-color yin-yangs are like one of the first things I tried to play with when I was setting. But you really lose a lot of the tension very quickly if you allow a third color. Like there's still some things that have to be true, but you run out of a lot of things. One thing I really want to play with more, I made a puzzle a long time ago called Red and Blue. It might have been one of the first puzzles that Ranks did of mine. It was basically a yin-yang puzzle, but with some cells that were allowed to be both colors, so you could sort of like break some of the standard connectivity rules. I'd like to play with that more, or see that played with more. It was I've not seen something like it since. At the time I was setting it, I didn't really know much about yin-yang, so I might try and play with it at some point now that I'm finally getting close to the end of making Secret Santa puzzles and various other puzzles for various other folks for various other purposes. I might try and do that. Oh, Eric, that is an awesome idea. It's an S-cell yin-yang, but the S-cells are also both colors. That is too good. That might have to happen. Oh, poor everyone if that happens, but it sounds like it sounds like a very easy and interesting idea to do that. Alrighty. Before I create more nightmares for myself, I better head off. Given all the opportunities to submit things, this would be a great thing to submit for Tristan's birthday, I think. Tristan would be very enthusiastic about the S-Cell Yin Yang full rank puzzle that Eric and Andrew Sarkis are going to collab set. But anyway, thank you all for hanging out. It's been a pleasure, and I will see you all around very soon. Bye for now.